Hello, and welcome to the Snoozy Scientist, where we explore the deepest mysteries of science, one sleepy yawn at a time. I'm so glad you're here tonight. Wherever you're listening from, this gentle corner of the universe was made for you, a calm space where science, curiosity, and stillness come together to help you drift into wonder. Tonight, we'll journey together to Mars to explore some of the most puzzling and hotly debated structures ever found on its surface. Scattered across this alien land are shapes and shadows that seem too deliberate to ignore, perfect lines in a place shaped by chaos, sharp edges in a world carved by wind and time. Some rise like monuments against the horizon. Others hide in plain sight, their outlines blurred by dust storms and distance. Are these the slow work of nature, or the remnants of something far older than our history, a story written long before Earth's first cities were built? For generations, we've pictured Mars as a dead, frozen wasteland. But with every image sent back from our rovers and orbiters, that image is beginning to crack. Because the more we look, the more hints we find that its past may have been far more complex and far stranger than we ever expected. A past that leaves behind clues carved into its surface, some with scientific explanations, others wrapped in mystery. Tonight, we're going to walk the Martian surface together, to stand before some of its most mysterious structures, the ones still giving scientists sleepless nights. Some will have answers, some will only raise more questions, and all of them will make you see the red planet in a way you never have before. Not as a barren wasteland, but as a planet holding on to secrets it's not ready to let go. Before we begin, if you're already enjoying this moment of quiet wonder, it would mean a lot if you gave this video a gentle like or subscribed for more sleepy science journeys like this. And if you don't mind, tell me in the comments where in the world you're watching from tonight and what time it is there. It's always a joy to see how far across our planet these sleepy science videos drift. So now, take a deep breath and let it go, because once you've seen what Mars is hiding, you may never see it the same way again. Let's begin. On a quiet slope of Mars, far from the dust trails of any rover, there lies a pattern that almost feels like a whisper from another world. Scattered across the red ground is a ring of large stones, some upright, some leaning, and some lying flat as though they had been toppled. At first glance, it could be nothing more than the result of rocks tumbling downhill or being jostled into place over millennia by the slow grind of erosion. But the longer you look, the more the arrangement seems deliberate, too circular, too even, too familiar. Images of the site taken from orbit show a shape that pulls at the mind's sense of recognition. The stones are not spread randomly. They seem to outline a near-perfect loop, each boulder spaced just enough to suggest intention. The resemblance to Earth's Stonehenge is impossible to ignore, and the moment that connection clicks, the imagination starts to wander. On our own planet, rings of standing stones mark some of the most mysterious sites in history, monuments aligned with the rising sun, ceremonial spaces, astronomical calendars carved in rock. So what does it mean to see something similar on Mars? Geologists, as always, lean toward the simplest explanations. They argue that circular patterns in nature are not as rare as they seem. A ring could form from the edges of an ancient impact crater, the rim slowly breaking apart into scattered boulders. Freeze-thaw cycles in Mars's colder epochs could have shifted the stones outward from a central point, much like patterned ground seen in Earth's Arctic regions. Over millions of years, wind could have carried away finer dust, leaving the heavier stones in place. In this reading, the Stonehenge effect is nothing more than geology arranging itself into a shape that by chance mirrors human architecture. but the pull of another explanation is strong. In the minds of many observers, the stones don't just happen to be in a ring, they are a ring. And rings, especially of megalithic proportions, have purpose. On Earth, such structures often align with celestial events. Could this Martian ring point toward the equinox sunrise as seen from millions of years ago? Could it have framed the horizon where certain stars or planets once rose? Was it a meeting place, a marker, or something ceremonial to beings we have never known? This is where the human brain steps into the story. We are wired to find patterns, even in chaos. The same instinct that lets us read words on a page or recognize a friend's face in a crowd is the one that lets us look at a scatter of rocks and see design. Psychologists call this pareidolia, and while it often explains away things like faces in clouds or animals in constellations, it can also fuel some of our most powerful moments of wonder. When we see a shape that echoes our own history, we can't help but imagine a shared purpose, a bridge between two worlds. What makes the Martian Stonehenge so compelling is the scale of the mystery. We do not yet have high-resolution, close-up images of each stone, no way to examine whether they have been carved, shaped, or moved. From orbit, shadows stretch from their edges like fingers pointing into the dust, hinting at their height and form, but withholding their secrets. The ring sits in silence, the air too thin to carry sound, the ground cold and ancient beneath it. Some researchers propose a middle ground between accident and intention, that the formation could be the remains of a geological structure later modified, perhaps subtly, by natural processes or even ancient life. In such a scenario, what we see now would be a palimpsest, a mix of the planet's raw geology and something added later, layered together so that one cannot be separated from the other. The mystery is deepened by the fact that this is not the only unusual stone arrangement found on Mars. Other rover and orbiter images have shown clusters, lines, and odd symmetries in rock placement. Most are dismissed as coincidence, but taken together, they form a background hum of what if that is hard to silence. The idea that somewhere, long before we walked the Earth, Mars might have had its own era of builders is not easy to prove, yet it is just as hard to completely dismiss. Every image of formations like this pushes us to consider that perhaps human history is not the only kind of history worth telling. The Martian Stonehenge sits as a silent invitation to imagine a past that stretches far beyond the reach of our planet, across the void to a world that once may have known hands, or minds, or forces, shaping stone into a circle beneath a different sun. And beyond that circle, the landscape stretches into the distance, dotted with yet more shapes that seem to call out for explanation. The year was 1976. NASA's Viking 1 orbiter had been circling Mars for months, photographing the planet's dusty surface in crisp black and white. Most of the images were exactly what scientists expected: endless plains of rock, scattered craters, the long shadows of mountains and ridges. But then, as the orbiter passed over a region in the northern hemisphere called Cydonia, one frame stopped the mission team in their tracks. At first glance, it looked like a hill, but not just any hill. The sunlight was falling across it in such a way that shadows deepened the hollows and ridges into something eerily familiar, a human face. You could make out what seemed to be eyes, a nose, and a mouth staring straight up into the void of space. The scale was staggering. The face stretched nearly 2 kilometers from end to end, the size of a small city. NASA released the image to the public with little fanfare, noting in a press briefing that it was simply a trick of light and shadow. They even said so directly. The shape was just a mesa, a natural formation, photographed at the perfect moment to resemble a face. But it was too late. The image had already taken on a life of its own. Newspapers ran the photo on their front pages. TV anchors asked whether Mars might once have been home to an intelligent species. People who had never cared about space exploration suddenly found themselves staring at this strange monument on a faraway world. For many, the timing of the discovery was electrifying. This was the 1970s, the height of the space age's public imagination. Humanity had walked on the moon just a few years earlier. Science fiction was thriving in books and film, and here was an actual NASA photograph showing what looked like the carved face of a giant alien statue. It was as if something out of a story had crossed over into reality. Over the decades that followed, the face on Mars became one of the most famous space images ever taken. It inspired documentaries, countless late-night talk show debates, and entire books dedicated to decoding its possible meaning. Some speculated it was a deliberate monument left by an ancient civilization as a message to anyone who might one day visit. Others imagined it could be the eroded remains of a vast city, with the face as its most prominent landmark. In these theories, Cydonia was more than just a region, it was the last trace of life on Mars. But scientists remained cautious. They knew the human brain has a quirk, a deep, hardwired tendency to recognize faces everywhere. This phenomenon, called pareidolia, is the reason we see shapes in clouds or imagine animals in the patterns of wood grain. On a survival level, it makes sense. Early humans who could quickly recognize faces and expressions had an advantage. But it also means we sometimes see meaning in randomness. Pareidolia was likely the reason this hill in Cydonia became so iconic. The Viking 1 image had captured it under a very specific lighting angle, where the low Martian sun cast deep shadows in the right places to trick the brain. Two dark spots became eyes, a ridge became the nose, a shadowed gully suggested a mouth, and the sheer size of it made the illusion all the more powerful. It didn't look like a small rock shaped like a face, but a colossal monument visible from orbit. Years later, NASA had the chance to look again. In 1998 and again in 2001, the Mars Global Surveyor returned to the Cydonia region with a much more advanced camera. This time, the images were sharper and captured under different lighting conditions. The new photos showed the hill in far greater detail, and the face all but vanished. Without the dramatic shadows, it was clear that the structure was just a rugged mesa, its surface broken by ridges and depressions, shaped over millions of years by wind and erosion. To many scientists, this confirmed what they had said from the beginning. There was no alien monument in Cydonia, only a geological formation. But to others, especially those captivated by the mystery, the new images didn't close the case. They argued that erosion could have softened the original shape over time, or that the true details might only be visible under certain lighting conditions. A few even suggested that the release of these images was part of an effort to downplay something far more extraordinary. The face on Mars, whether artifact or illusion, has never faded from public fascination. Even today, decades later, it appears in documentaries, podcasts, and YouTube deep dives. For many, it's not just about the truth of the image, it's about the feeling it created the first time they saw it. That instant of recognition, the breathless moment when the human brain looked at a barren alien world and saw something staring back. And perhaps that's why the face on Mars remains so powerful. Not because it proves life once lived there, but because it reminds us that we want to find it. We want to believe there's a connection between our world and that distant frozen desert. And even if science tells us it's just a trick of the light, the idea that Mars might hold monuments, real or imagined, keeps us looking. Just beyond Cydonia, in that same vast northern region, lies another formation that would capture imaginations almost as fiercely. It wasn't a face this time, but something even stranger, a massive five-sided pyramid rising from the dust. And like the face, it would stir its own storm of questions. Not far from where the face on Mars lies in the dusty expanse of Cydonia, another structure began drawing its own wave of attention. It didn't look like a face. It didn't look like a city. But from the moment it was first spotted in NASA's Viking 1 photographs, it had something that instantly stood out: shape. The object appeared to be a massive, sharply defined pyramid, but not quite like the ones we know from Earth. It had an unusual geometry: 5 distinct sides, each meeting at crisp angular lines, as if precision carved. From above, the edges formed a symmetry that seemed too neat, too exact for something shaped purely by the random forces of nature. It towered over the surrounding terrain, casting long shadows across the plains, its base stretching for kilometers. When this image began circulating in the late 1970s, it was quickly linked to the already growing mystery of the face on Mars. The two formations weren't far apart, both located in the Cydonia region, as if they might be part of the same complex. Some researchers in the fringe and speculative science community pointed to this proximity as a kind of architectural clue. If the face was some kind of monument, perhaps the pyramid was part of a larger layout, maybe even an ancient Martian city now buried in sand and time. The name D&M Pyramid came from its discoverers, Vince DiPietro and Gregory Molinar, two NASA image analysts who studied the Viking photographs closely. They were among the first to highlight the pyramid's unusual 5-sided shape, arguing that the angles and alignments seemed deliberate. According to their measurements, the faces of the pyramid appeared to have proportions that echoed certain geometric principles, possibly even the mathematical constants we see in ancient structures on Earth. For believers in an artificial origin, this was more than coincidence. They saw the pyramid as a deliberate construction, a massive stone-like structure left behind by a civilization capable of shaping entire landscapes. Some even suggested it might be hollow inside, an ancient vault, a marker, or a monument designed to withstand millions of years of erosion. The fact that the pyramid's orientation appeared to align loosely with other features in the Cydonia region only added fuel to the theory. To those captivated by the mystery, it felt like Mars was revealing the ruins of an ancient and intelligent past, one careful photograph at a time. But for planetary geologists, the excitement was more cautious. They argued that the D&M Pyramid's appearance could be explained through natural processes. On Mars, erosion works differently than on Earth, with outflowing water and with a much thinner atmosphere. Wind and temperature changes shape the land in slow but dramatic ways. Over millions of years, the combination of dust storms, freeze-thaw cycles, and impact events can create shapes with striking symmetry. They pointed out that polygonal and multi-sided hills are not entirely uncommon in nature, especially in regions with layered bedrock and a history of tectonic or volcanic activity. On Earth, there are mesas and ridges that, when viewed from above, take on shapes like triangles, rectangles, or pentagons. Under the right lighting, these natural formations can appear even more geometric than they really are. Still, the debate refused to fade. For one thing, the D&M Pyramid's 5-sided symmetry is unusual even by geological standards. Perfectly even pentagons are rare in nature, and the Viking photographs captured angles that were difficult to dismiss as entirely accidental. Skeptics acknowledged that while the formation could be natural, it was certainly one of the more striking examples of nature's geometry on Mars. Part of what keeps the D&M Pyramid controversial is the same thing that made the face on Mars so famous: the limitations of the original imagery. The Viking 1 camera, while revolutionary for its time, had nowhere near the resolution of modern spacecraft. The pyramid was photographed from hundreds of kilometers above, with each pixel representing tens of meters. That meant fine details were lost, and the interplay of light and shadow could easily exaggerate the sense of sharpness and precision. Later missions, like the Mars Global Surveyor and Mars Reconnaissance Orbiter, have revisited the Cydonia region with far better imaging equipment. In the higher resolution images, the pyramid appears more weathered, its sides less perfectly straight, and its symmetry less exact than it first seemed. To many scientists, these newer images proved that the D&M Pyramid was simply a mesa or hill shaped by erosion into a polygonal form. But for those invested in the anomaly, the updated photographs didn't end the mystery, they only deepened it. Some argue that the later images were taken from angles or lighting conditions that obscure the formation's original features. Others believe the erosion explanation doesn't account for the specific proportions and alignments recorded from the Viking data. And for some, the very fact that the D&M pyramid exists so close to the face is enough to suggest a pattern worth exploring. In the public imagination, the D&M pyramid has taken on a life beyond geology. It appears in books about ancient astronauts, in speculative maps connecting supposed structures across Cydonia, and in online discussions about whether humanity might one day explore it in person. Its combination of scale, symmetry, and mystery has made it a symbol not just of the search for life on Mars, but of the tension between what science can explain and what it still leaves open. And just beyond it, scattered across the Martian surface, are other shapes that add to that tension. Long, reflective tubes twisting across the landscape like glassy veins. These would earn their own nickname and stir their own theories, drawing the eyes of scientists and dreamers alike toward a new kind of Martian mystery. In May of 2022, as the Curiosity rover trundled slowly across the rugged terrain of Gale Crater, one image it captured sent shockwaves far beyond the world of planetary science. It was a simple frame, taken like countless others before it, a swath of rocky Martian hillside, shaded in the dusty tones of the red planet. But near the center of the shot was something that, to the human eye, seemed almost impossible to ignore, a small dark opening carved cleanly into the rock. It was the kind of shape that stops you mid-scroll, a near rectangular gap framed by vertical and horizontal lines, so precise, so deliberate looking, that the mind instantly whispers a single word: doorway. The image went viral almost instantly. News outlets ran it alongside breathless headlines. Social media feeds lit up with side-by-side comparisons to ancient Egyptian tomb entrances, fortress gates, and even the doorway of a home. The scale of it was modest, about the size of a small dog, but that almost made it more eerie. Too small for a person, too exact for randomness, or so it seemed. People asked themselves and each other the question they've been asking about Mars for decades. Could something have built this? NASA, predictably, had a more measured answer. Their scientists were quick to point out that Gale Crater is a place sculpted by billions of years of wind, dust, and geological shifts. They explained that the doorway was not an actual entrance to some hidden chamber, but a naturally occurring fracture in the rock, the result of stress and erosion breaking it along clean fault lines. They even estimated the gap was only about 30 centimeters tall, making it far too small to be a grand alien threshold. And yet, the explanation didn't kill the fascination. In fact, for many people, it deepened it. Because even knowing the science, there's something about seeing perfect geometry in the midst of raw, chaotic nature that feels unsettling. On Earth, we're used to landscapes being messy, jagged edges, uneven slopes, random patterns. Straight lines and sharp right angles are so rare in nature that our brains are wired to associate them with intention, architecture, design, intelligence, This is why clean geometric shapes on Mars, whether it's a square shadow, a triangular ridge, or in this case a doorway-like cut, create such a powerful reaction. It's not just that they stand out visually, it's that they spark a deeply human instinct to see order in chaos. Psychologists have a name for this, pareidolia, the tendency to perceive familiar patterns, especially faces or structures, where none were deliberately made. It's the same quirk of the mind that lets us see castles in clouds or animals in the patterns of the stars. But when the backdrop is Mars, a place we've long dreamed might have once been alive, that instinct feels less like a trick and more like a hint. For the people who looked at the Curiosity photo and couldn't shake the feeling that it meant something, the doorway became more than an image. It became a symbol, a reminder that for all the high definition pictures, precise measurements, and geological models, there's still a layer of Mars we can't quite touch, a layer that lives in questions we aren't ready to answer. It also didn't help that Gale Crater is no ordinary patch of Martian ground. This vast depression, about 96 miles wide, has been one of NASA's most important exploration sites precisely because it holds a complex geological history. Its layers of rock tell the story of a planet that once had rivers, lakes, and perhaps even conditions suitable for life. Curiosity was sent there to read that story, one chapter at a time, and now here was a doorway nestled in one of those pages. The setting alone made it harder for the public to dismiss. Of course, scientists and skeptics continued to urge caution. The perspective in photographs can be deceptive. A play of light and shadow can make small features look grand or distort their shape entirely. Without standing there in person, without touching the rock, it's impossible to fully grasp its scale and texture. Still, the precision of the lines in that image was undeniable. The framing rocks looked almost like carved pillars. The shadow inside the gap gave it depth, like it might lead somewhere. And that feeling, the sense that this could be the threshold to another world, was what captured so many imaginations. Over time, the initial media frenzy faded. Other images from Mars took its place in headlines, but for those who lingered on it, the Gale Crater doorway remains lodged in the mind, a quiet question mark carved into Martian stone. And perhaps that's the real reason shapes like this draw us in so powerfully. Not because we truly expect to find an alien civilization frozen in time, but because in that small dark gap, we see the possibility of a bigger story. One we don't yet understand, one we can't yet explain. And as curiosity continues its slow crawl across the crater, sending back image after image of wind-scoured ridges and dust-blown valleys, that feeling, the urge to peer into the unknown, only grows stronger, because somewhere out there, beyond the next slope or around the next bend, there might be another shape, another shadow, another impossible straight line waiting to be found. Phobos, the larger of Mars' two moons, is not the kind of place that usually makes headlines. It's a lopsided, crater-pocked rock, barely 17 miles across, with gravity so weak that a running leap could fling you straight into space. It tumbles around Mars every 7.5 hours, close enough that the red planet would fill half the sky for anyone standing there, if there were anyone to stand there at all. For decades, it was considered little more than a captured asteroid, a battered companion in Mars's orbit. But then, one strange photograph changed the way people looked at it. The image was taken by NASA's Mars Reconnaissance Orbiter, high above the dusty moon. Most of what it captured was typical Phobos scenery: ridges, craters, scattered boulders thrown up by ancient impacts. But among them was one object that didn't quite belong. Rising from the surface was a tall, narrow structure, rectangular, with sharp, well-defined edges. It stood alone, casting a long, thin shadow across the barren ground. It wasn't shaped like the irregular rocks around it. It wasn't slumped or rounded. It looked intentional. Scientists quickly dubbed it the Mars Monolith, though technically it was on Phobos, not Mars itself. The nickname stuck, partly because it felt like something out of a science fiction movie, a nod to the mysterious alien slab in 2001, A Space Odyssey. The resemblance was uncanny: smooth-looking sides, a geometric form, and an eerie isolation in the middle of an empty landscape. Its proportions were strange too, towering in a way that felt unnatural for a simple chunk of rock. For the public, this was enough to spark a firestorm of theories. Was it a relic of an ancient civilization that had once lived on Mars and left its mark on its moon? Could it have been placed there deliberately, either as a beacon or a monument? Or was it, as some speculated, the remains of something far more recent, a piece of alien technology, hidden in plain sight? That speculation only intensified when an unexpected voice joined the conversation: astronaut Buzz Aldrin. In an interview, Aldrin, the second man to walk on the moon, spoke about Phobos in a way that made ears perk up. "We should visit the moon of Mars," he said. "There's a monolith there. When people find out about that, they're going to say, 'Who put that there?'" It was the kind of statement that could have been a casual remark, a light-hearted reference to the photo, but coming from a man who had traveled through the void of space, it carried weight. Almost overnight, the Mars monolith was elevated from an obscure geological oddity to a staple of conspiracy forums, late-night talk shows, and space documentaries. People dissected every pixel of the original image, measuring shadows to estimate its height, sharpening the edges to make it appear even more unnatural. Some swore they could see tool marks. Others believed it was a fragment of something much larger, buried beneath the surface. NASA, of course, had a far more grounded explanation. To them, the monolith was simply a boulder, a large chunk of rock that had broken off during a meteor impact and rolled to its resting place. The sharp edges and tall profile, they said, were just the product of Phobos's low gravity and lack of erosion. Without wind, rain, or atmosphere to wear it down, rocks on airless bodies can keep their jagged shapes for millions of years. From a geological standpoint, there was nothing impossible about it. But here's the thing: NASA's explanation didn't close the case for many people, because even if it was just a boulder, its placement was strange. Phobos is littered with debris, yet this object stood so distinctly apart from everything around it, almost like it had been arranged. And even if nature had placed it there, the odds of it forming such clean geometric lines seemed, to the untrained eye, improbably low. Humans are wired to notice patterns, and this one was impossible to ignore. Part of the intrigue also came from the location itself. Phobos is a mysterious moon in its own right. Its orbit is so close to Mars that tidal forces are slowly pulling it inward. One day, in perhaps 50 million years, it will either crash into the planet or break apart into a ring of debris. Some scientists have speculated that it might even be hollow in places, with unusual density readings hinting at large internal cavities. To conspiracy theorists, that made it the perfect hiding place for something artificial, and the monolith, in their eyes, was the first piece of evidence. The truth, as it often is with space, remains elusive. No spacecraft has ever landed near the Mars monolith, and no rover has rolled up to give us a close look. From the distance of orbital photography, it's just pixels, sharp, curious pixels, but still too few to reveal the finer details. Until we see it up close, we're left in that limbo between certainty and wonder, where explanations and imagination live side by side. And maybe that's why the Mars monolith has held the public's attention for so long. It's not just the shape, or the shadow, or even Buzz Aldrin's teasing words. It's the fact that in the middle of a lifeless, airless moon, there stands a solitary object that looks like it was placed there with purpose. whether that purpose is geological happenstance or something we've yet to understand. That's the part that keeps us looking twice. Because if there's one thing space has taught us, it's that sometimes the most haunting mysteries aren't the ones hidden far away in distant galaxies. Sometimes they're the ones just close enough to see, but still too far to touch. From far above Mars, the planet's surface can appear like a canvas brushed with soft reds and browns, the muted palette of a frozen desert world. But if you look closer, if you peer down through the high resolution eyes of a satellite, you begin to notice patterns that break the monotony. Not craters, not dunes, something stranger, stretching across certain regions, especially along ancient volcanic plains, are long, winding forms that almost seem to slither through the landscape. They're pale against the darker terrain, sometimes glinting faintly as if they've caught the sun at the right angle. From orbit, they look eerily like gigantic worms, translucent, segmented, and sprawling for miles. Scientists gave them a more clinical name: sinuous ridges and collapsed tubes. But to the public, the nickname came naturally: the glass worms of Mars. The first time these tube-like structures caught serious attention was when high-resolution imagery from the Mars Global Surveyor and later the Mars Reconnaissance Orbiter revealed their startling detail. From above, they didn't have the jagged edges you'd expect from cliffs or cracks. Instead, they appeared smooth, almost uniform, with a consistent width along their entire length. In some places, they twisted gently, mimicking the lazy curves of a river. In others, they ran perfectly straight, as if someone had drawn them across the ground with a ruler. The most striking thing about them wasn't just their shape, but their strange reflectivity. When the light hit them just right, certain stretches gleamed brighter than the surrounding rock and dust. On a planet known for its dull rust-colored terrain, this was unusual. Reflectivity suggests different material properties, something denser, smoother, perhaps even glassy, and that was enough to set imaginations on fire. One of the leading scientific explanations for these formations points to Mars' volcanic past. Billions of years ago, the planet was geologically alive, with massive volcanoes pouring rivers of molten rock across the land. On Earth, when lava flows quickly, the surface can cool and harden, while molten rock continues to move beneath it. Eventually, the molten flow drains away, leaving behind hollow tunnels called lava tubes. These tubes can survive for millions of years, preserved as long as the planet's weather and geology remain gentle. On Mars, with no rainfall, no thick atmosphere, and little tectonic activity, such structures could last for eons. Over time, some of these tubes might have partially collapsed, creating the segmented, worm-like ridges seen from orbit. The glass effect, scientists argue, could come from volcanic glass, the shiny, hardened remains of lava that cooled quickly before crystallizing. This would explain both the shape and the unusual brightness in the images. But that explanation, while satisfying to many geologists, hasn't stopped others from proposing far more speculative ideas. Some see the glassworms not as the scars of ancient lava flows, but as evidence of something built, enormous tunnels carved with purpose. The reflective quality, they argue, might not be natural glass at all, but some form of ancient construction material now half buried in dust. It's not hard to see why this theory took hold in certain circles. Lava tubes, after all, are not just natural wonders, they're also prime real estate for shelter on hostile worlds. On Earth's moon, scientists have suggested that astronauts could one day live in lava tubes to avoid dangerous radiation and micrometeorites. On Mars, ancient life, or even intelligent life, might have had the same idea. If a civilization ever existed there, underground tunnels would have been one of the safest places to survive the planet's harsh climate shifts. And here, The speculation deepens. What if these worms are the remains of such ancient refuges, their roofs partially caved in over millennia, exposing gleaming interior surfaces to the Martian sky? What if their winding paths were once transport routes, storage corridors, or even living spaces? Without a rover or lander up close, there's no way to confirm or deny such ideas, and in the vacuum of certainty, mystery thrives. Adding to the intrigue, the glass worms often appear in regions already rich with geological and atmospheric puzzles. Some snake along the flanks of volcanoes, others cut through ancient floodplains, and still others run parallel to deep fissures in the crust. Their distribution doesn't seem entirely random, and that only fuels the idea that they may have a connection to past water, heat, or even in the eyes of the most hopeful, life. The reflectivity, too, remains a sticking point. While volcanic glass is a reasonable explanation, there's something visually uncanny about seeing such smooth, light-catching shapes in a place that has been blasted by meteorites and scoured by dust storms for billions of years. Unlike jagged rocks or irregular boulders, the glass worms keep their form as though they were laid down yesterday, and under certain lighting, they seem to shimmer as if trying to be noticed. From the comfort of Earth, we can only study them as lines in a photograph, trying to tease meaning from pixels. Zoom in too much, and the image dissolves into blurs. Zoom out, and the sense of scale is dizzying. These aren't tiny features, but sprawling, monumental traces of something ancient. Whether the work of nature or something else entirely, they hint at a Mars that still holds secrets under its skin. And as the satellites keep circling, sending back new images with sharper focus and richer detail, the glass worms remain one of those rare Martian features that seem to stare back at us. Smooth, pale, and impossibly long, they run like veins across the planet's face, and for now, we can only wonder what once flowed through them. On a cold, wind-scoured plain of Mars, the Curiosity rover paused its slow crawl and turned its camera toward a scattering of stones. At first glance, they looked like countless others it had photographed before, eroded, dust-streaked, silent. But when the images traveled across millions of kilometers to Earth and appeared on our screens, one particular rock seemed to stare back. It had the rounded dome of a cranium, the dark hollows where eyes should be, and the subtle curve of cheekbones. A trick of light and shadow transformed it from just another piece of Martian debris into something deeply, hauntingly familiar, a skull. The human brain is wired for recognition. Long before we had writing or technology, our survival depended on spotting faces in the half-light of forests and deserts. That instinct, honed over millions of years, still drives us today. We can see a face in the bark of a tree, the outline of an animal in the clouds, or a smile in the headlights of a car. Scientists call this phenomenon pareidolia, the mind's ability to impose patterns, especially human ones, onto random shapes. On Earth, pareidolia is a harmless curiosity, something we might laugh about when we notice a potato chip shaped like a famous person. But when it happens on another planet, when a rock on Mars appears to wear the mask of something human, the effect is electric. For a moment, the barren wasteland feels alive. The distance between worlds shrinks. When NASA released the rover's skull rock photo, the reaction was immediate. The image spread through news outlets and across social media, sparking debates, jokes, and more than a few conspiracy theories. Some saw it as proof, or at least a tantalizing hint, that Mars had once hosted intelligent life. Others dismissed it as just another case of pareidolia, amplified by wishful thinking. And then there were those who simply felt unsettled, unable to shake the eerie sensation of being watched from a place that should be empty. What made this particular rock so captivating wasn't just its resemblance to a skull, but the setting in which it was found. The Martian landscape, with its long shadows and ochre haze, already feels alien and unwelcoming. Against that backdrop, the sight of something so familiar, the universal symbol of mortality, stirs emotions deeper than curiosity. It touches on something primal, the fear of death, the mystery of life, and the age-old question of whether we are alone. The skull shape itself wasn't perfect. The eye sockets were uneven, the jawline rough and fractured, but these imperfections only seemed to make it more convincing, as if it had been weathered over centuries. The mind fills in the missing pieces, smoothing edges and darkening shadows until the illusion feels complete. In truth, this is what pareidolia does best. It takes an incomplete signal and writes a story over it. Scientists, of course, are quick to explain such shapes. On Mars, erosion is the great sculptor. Wind carrying fine dust can slowly carve rock into strange forms, and temperature swings can fracture stone in ways that mimic organic shapes. Combine that with the harsh angled sunlight filtering through thin atmosphere, and you have a perfect recipe for illusions. The skull rock is no more proof of life than the face on Mars, the Martian Bigfoot, or the countless other shapes captured by rovers and orbiters over the years. But logic doesn't diminish fascination. If anything, the explanations only highlight how easily the human brain leaps to conclusions and how deeply we yearn for connection with something beyond our world. For many, the skull rock photo became a kind of Rorschach test. What you saw in it revealed as much about your hopes and fears as it did about Mars itself. Some artists took the image and ran with it, coloring the stone in bone-white hues or setting it against star-filled skies, imagining it as the relic of a long-dead Martian race. Others used it as a symbol of the planet's silence, a reminder that even if life once existed there, it may have ended long ago. In online discussions, people traded theories ranging from ancient burial grounds to petrified remains, weaving entire civilizations into the space between the pixels. And yet, the reality remains. This was most likely just a rock, shaped by time, wind, and chance. But here's the thing, even knowing that doesn't make it any less powerful. In the sterile world of scientific data, moments like this are rare. They remind us that exploration is not just about measurements and analysis. It's also about the moments when an image makes your heart skip, when the emptiness of another planet feels for a split second inhabited. The skull rock remains a favorite in collections of Mars anomalies, not because it proves anything, but because it demonstrates so vividly the meeting point between a silent alien world and the restless, meaning-seeking human mind. And somewhere beyond that dusty plain, the Curiosity rover kept rolling on, its cameras ready to catch the next trick of light and shadow that might set our imaginations alight again. In the middle of a vast Martian plain, where dust storms wander endlessly and the wind's voice is the only sound, something slender and impossibly tall rises from the ground. It's not broad like a mesa or sprawling like a dune. It is a needle, a single sharp spire reaching toward the salmon-colored sky. This is the formation that has become known as the Shard. The photo that revealed it was taken by one of NASA's Mars rovers as it trundled over a landscape littered with boulders and broken rock. In the frame, the shard stands apart, a dark, narrow silhouette that seems out of place in a land shaped mostly by erosion and chaos. Its sides appear smooth, its tip tapering upward with a kind of deliberate grace. If you were to imagine an ancient obelisk, weathered by time but still proud, it would not look far from this. The mind, confronted with such a shape, quickly begins to wonder, was this formed by nature, or was it made? And if made, then by whom, and for what? The shard's most striking quality isn't just its height, but its fragility. It looks so thin, so precarious, that even on Earth, Under a blue sky and gravity's full pull, it would seem unlikely to stand for centuries. Yet here it is on a planet where winds can howl at 60 miles per hour, temperatures plunge to 100 degrees Celsius, and quakes occasionally ripple beneath the crust. Geologists, naturally, have their explanations. One theory is that the shard could be the eroded remnant of a larger rock formation, the last surviving pillar after softer surrounding material was worn away by countless years of sand-blasting winds. The spire's slender shape might be the result of a fracture in a once solid mass of stone, with erosion carving away the weaker material along the break until only the toughest, most resilient piece remained. But that explanation, while plausible, doesn't fully satisfy the curiosity the image stirs. The shard's clean lines and solitary stance seem almost purposeful. This is where comparisons to ancient obelisks come in, not the kind shaped by wind and water, but the ones placed by human hands. On Earth, obelisks were built to mark sacred places, honor rulers, or align with celestial events. They were messages in stone, meant to outlast the people who built them. The shard, standing silent on Mars, seems to hum with that same energy, a monument to something unknown. Its surface texture adds another layer to the mystery. In the rover's images, parts of the spire reflect light differently than the surrounding rocks, as if it is made of a slightly different composition. Some parts look jagged and broken, others almost polished, as though they have been shielded from erosion or shaped by forces not yet understood. Could it be volcanic in origin, the hardened throat of an ancient lava vent? Could it be the petrified remains of a mineral deposit left behind when water seeped through the ground eons ago? The improbability of its survival is what captures so many imaginations. On Earth, slender natural spires do exist, like the hoodoos of Bryce Canyon or the pinnacles in Australia's desert, but they are constantly eroding and collapsing. On Mars, where the atmosphere is thin and there is no liquid water to accelerate erosion, such a structure could, in theory, endure for far longer. But even so, the thought of a narrow stone needle standing upright for millions of years, untouched by all that time, feels like a miracle of balance and luck. Some who have studied the photos suggest that the shard may be far smaller than it appears, perhaps only a few inches tall, and that its grandeur is simply a trick of perspective. Without a clear scale reference in the image, it's impossible to be certain, but this uncertainty only feeds the fascination. The idea that it could be towering or tiny, yet still possess such an uncanny shape, leaves room for endless speculation. Online discussions about the shard often divide into two camps. One side points to the well-understood processes of geology, arguing that given enough time, wind and dust can create almost any shape. The other side sees something else, a symbol, a relic, maybe even the last fragment of a structure built by hands we've never met. Both sides are in their own way, responding to the same pull, the deep human instinct to search for meaning in the unexplained. As the rover rolled past, it captured only a handful of images of the shard before moving on, leaving the questions behind it in the dust. No further close-up study has been done, and perhaps none ever will be. The spire still stands, alone on its plane, enduring storms and seasons in a silence as old as the planet itself. Somewhere, under that dim pink sky, it casts its narrow shadow, a sliver of darkness stretching across the red ground, as if marking a place on a map we haven't yet learned to read. And just beyond it, in the endless expanse of Martian terrain, more shapes wait for discovery. From high above Mars, where the planet's rust-colored plains stretch out in every direction, a strange shadow once caught the attention of scientists and enthusiasts alike. In a region otherwise unremarkable, The satellite images showed a shape unlike the jagged chaos of nearby rock formations. It was long and sleek, with a gentle curve along one side, almost like the hull of an enormous ship resting silently in a sea of dust. The bow seemed to taper into a point, while the stern widened slightly, giving the eerie impression of something built rather than born from stone. When the first images made their way online, the reaction was swift. People saw not just a rock, but the ghost of a vessel that might have sailed an ocean long vanished from Mars. Some imagined it as the remains of an alien ark run aground when the Martian seas receded. Others pictured it as a relic from a lost civilization buried by the slow crawl of dust storms over millions of years. The idea that a ship could exist on a planet we've always thought of as dry and barren added another layer to Mars's already rich tapestry of mysteries. The human mind is quick to give meaning to shapes, especially when those shapes resemble something familiar. In this case, the resemblance was almost too perfect. The rounded bow, the sloping sides, the shadows that suggested depth and contour. Under the right lighting, the illusion deepened, making the ship appear to be resting at an angle, half sunk into the surrounding terrain, as though stranded in a final moment of stillness. Geologists, of course, offered more grounded explanations. Mars is no stranger to erosion, and its thin atmosphere, though less protective than Earth's, still allows for powerful winds that can sculpt the surface in surprising ways. Over time, those winds can strip away softer material, leaving behind harder rock that takes on unexpected forms. Add to that the constant bombardment of meteorites and the effects of temperature changes, where rocks expand in the daytime heat and contract in the bitter cold of night, and you have a recipe for all manner of strange shapes. Lighting plays its own tricks on the Martian surface. Because the sun sits lower in the sky during certain parts of the Martian year, shadows stretch longer, carving sharp contrasts across ridges and valleys. These shadows can exaggerate depth, highlight angles, and hide imperfections that would break the illusion. What might look like the smooth curve of a hull from one angle could reveal itself as a jagged cliff from another. But in still photographs with no movement to betray the truth, the mind fills in the missing pieces, and what it fills them with is often the most compelling part. The shipwreck formation became a perfect example of what's known as an optical illusion in planetary imaging. Much like the face on Mars decades earlier, the image drew power from its ability to spark the imagination. It didn't matter that follow-up images from different perspectives showed a more irregular, rocky shape. The original photo had already planted itself in people's minds, and once you see a ship in the dust, it's hard to unsee it. What makes this illusion so captivating is the setting itself. Mars has no oceans today, but we know it once had vast bodies of water, lakes, rivers, and perhaps even seas that covered entire regions. Evidence of shorelines, riverbeds, and sedimentary layering points to a past where water shaped the land for millions of years. So when a shape that resembles a vessel appears in satellite imagery, it collides with that knowledge in an irresistible way. If Mars had oceans, could it also have had ships? If it had ships, could it have had sailors? And if it had sailors, what happened to them? Such questions keep the shipwreck alive in conversations about Martian anomalies. Even among scientists who accept the geological explanation, there's an acknowledgement that these images serve a purpose beyond just sparking conspiracy theories. They remind us that exploration is as much about curiosity as it is about certainty. Without curiosity, there would be no reason to send rovers, no reason to study each crater and ridge, no reason to wonder about a planet that has been lifeless or perhaps quietly alive for eons. From orbit, the shipwreck still lies where it always has, its contours catching the light differently with each passing season. Dust storms sweep over it, sometimes burying its features, sometimes revealing them in sharper relief. Rovers have yet to visit it up close, so its texture, composition, and true shape remain partly a mystery. And perhaps that is what keeps it compelling, the sense that even in an age of high resolution imaging, some things on Mars still wait for a closer look. Just beyond that long shadowed hull, the Martian surface offers yet more puzzles, formations that look like they might have been shaped by hands or tools, yet could just as easily be the work of wind, ice, and time. Across the Martian horizon, there are places where the land rises in great flat topped plateaus, their sides sheer and weathered, like the walls of an ancient fortress. In other regions, thin spires stretch toward the pale pink sky, standing alone against the endless plains. From orbit, they resemble the remnants of grand halls and watchtowers. At ground level, through the eyes of a rover, they could be mistaken for the crumbling remains of a lost city. Temples without roofs, columns without ceilings, doorways that lead nowhere. These are not human creations. They are the work of wind, sand, and unimaginable time. Mars, though dry now, was once shaped by water, and later, when the rivers vanished, the planet's thin but persistent atmosphere took over the role of sculptor. For millions of years, dust storms scoured its surface, wearing away softer rock and leaving behind only the most stubborn formations. The result is a landscape that looks eerily familiar, not because we've seen it before on Mars, but because we've seen its cousins here on Earth. In the deserts of the American Southwest, towering mesas rise above the flatlands, carved by the same patient forces of erosion. Monument Valley, with its isolated buttes and pinnacles, has a striking resemblance to some Martian landscapes, so much so that movie directors have used its scenery to stand in for alien worlds. In Turkey's Cappadocia region, soft volcanic rock has been shaped by wind and rain into spires and cones, so otherworldly that they seem almost imagined. And in Egypt, wind sculpted rock outcrops can mimic the silhouettes of buildings or statues. When we see these shapes on Earth, our minds rarely jump to aliens built this. We know the forces at work here because we can stand in these places, feel the grit of sand against our skin, watch the shadows change with the sun. But when a similar formation appears in an image from Mars, viewed from millions of kilometers away, the context shifts. Distance turns every detail into a mystery. Without the sound of the wind or the scent of the dust, we rely on sight alone, and sight is easily tricked. There's a reason our brains so quickly connect these shapes to architecture. Humans are pattern seekers by nature. This tendency, called pareidolia, helps us spot familiar forms, even in randomness: a face in the clouds, an animal in the shape of a tree branch, or in this case, a temple in a pile of stone. Our ancestors relied on this instinct for survival. In the ancient past, spotting the outline of a predator in the brush could mean the difference between life and death. Over millennia, that instinct grew into something more: the ability to see meaning, even intention, in the shapes around us. On Mars, this instinct meets a stage perfectly set for the imagination. The wind there can strip away layers of rock in neat vertical lines, carving pillars that look like columns. It can scoop out alcoves that mimic windows, or cut through plateaus to create passages that resemble corridors. In low-angle sunlight, the shadows deepen these features, making them seem impossibly precise. And because Mars' thin atmosphere doesn't scatter light the way Earth's does, the contrast between light and dark is sharper, lending the temples an even more architectural appearance. Some formations appear to stand in careful alignment, almost like a courtyard surrounded by walls. Others rise in isolation, as if they once supported a roof, long since lost to time. To the human mind, such arrangements beg for a story. Were these gathering places, observation towers, monuments to something we have no record of? Scientists, for their part, trace their origins to the slow, grinding work of erosion, pointing out that similar shapes arise in countless environments without the touch of intelligent design. Yet the allure remains. Even the most seasoned planetary geologist can't deny that these formations stir something deeper than curiosity. They feel like evidence, not in the scientific sense, but in the emotional one. Evidence that the past of Mars was more than dust and rock. Evidence that there might have been a before that we have only begun to imagine. As rovers send back more images of these wind carved mesas and pillars, each new angle adds to the illusion. Sometimes the structures look taller and grander than before. Other times, a shift in perspective reveals their irregular, weather beaten edges, breaking the spell. But just as quickly, another formation appears in another crater or valley, starting the cycle over again. The pull between knowing and wondering, between geology and imagination. And beyond these temples lies even stranger geometry, shapes that, from above, seem to defy the randomness of nature. From high above the Martian surface, in the pale light that turns the planet's dust to shades of copper and gold, one particular formation catches the eye, a broad plateau, its edges marked not by random jagged lines, but by shapes that seem almost too orderly for nature. Hexagons, perfect, repeating, six-sided outlines etched into the land like the tiles of some ancient courtyard. The sight is strange enough to make the mind pause. Geometry is not something we expect from a wild, untouched landscape, yet here it was, sitting under the thin Martian sky, as if deliberately arranged. The human brain has a peculiar relationship with geometry. We recognize patterns instantly, a trait that helped our ancestors find order in chaos, predict the seasons, and build civilizations. So when confronted with clean, repeating shapes in nature, especially somewhere as remote and lifeless as Mars, we feel an immediate pull to understand them. Could they be artificial? Was there a mind behind their creation? Or could the forces of geology alone have carved them so precisely? Scientists have long known that hexagonal patterns can emerge naturally under certain conditions. On Earth, one of the most famous examples is the Giant's Causeway in Northern Ireland, a stretch of coastline where tens of thousands of interlocking basalt columns rise from the sea. They look as though they were sculpted by a master stonecutter, yet they were formed more than 50 million years ago when molten lava cooled and contracted. The cooling process caused the rock to fracture in a way that distributed stress evenly, and the most efficient shape for that was a hexagon. A similar process could explain Mars's hexagonal plateau. Billions of years ago, the planet's surface was volcanically active, with molten rock flowing and cooling across vast plains. If conditions were just right, if the cooling was slow and uniform, cracks would have formed in neat repeating lines, segmenting the surface into hexagonal shapes. Over time, wind erosion could have deepened the outlines, making the pattern even more striking from above. Yet while this is the scientific explanation, the image itself still stirs something more mysterious. The plateau's hexagons seem to hold their alignment over a surprisingly wide area, as if they were part of a larger design. Some people see in them the remnants of a colossal floor, the foundation of a structure so ancient it has long since vanished. Others imagine an alien agricultural grid, or the patterned surface of a landing platform. These ideas thrive not because there's strong evidence for them, but because the geometry feels deliberate in a way that randomness rarely does. On Earth, we have other examples that blur the line between geology and artistry. In Iceland, cooling lava flows have created sprawling fields of hexagonal columns that look almost like the walls of a fortress. In the American West, dried up lake beds sometimes crack into repeating polygons, formed as the mud shrinks under the sun's heat. In Antarctica, patterns of hexagons can emerge in sea ice, sculpted by the shifting temperatures and currents. All of these occur without any human or alien intervention, yet each one can stop a person in their tracks and make them wonder. Mars' version carries an added weight because of where it is. Every unusual shape on the red planet becomes a canvas for speculation. Without the ability to walk its surface and feel the rock under our fingers, we rely entirely on images, and images can leave just enough unanswered questions to fuel decades of debate. The hexagonal plateau is no exception. Some researchers point to its uniformity as proof of a specific volcanic history. Others note subtle irregularities that suggest the pattern might not be as perfect up close as it appears from orbit. From a rover's eye level, the scene would be different, not a giant honeycomb laid neatly across the ground, but a rough, weathered surface with cracks and ridges, dust piled in the gaps, and stones scattered over the shapes. Yet from space, the illusion of precision holds, reminding us how perspective can change everything we think we know. And just beyond this plateau, the Martian surface reveals another kind of geometric arrangement, one that doesn't spread across a flat plane, but rises into grid like formations that seem to hint at the outlines of something once built. In the heart of Mars's broad, flat Elysium Planitia, where the dusty horizon stretches out in all directions like an endless ocean of rust, satellite cameras have captured something that seems to defy the chaotic nature of geology. From high above, the surface appears etched with lines, long, straight ridges, and sharp right angles that seem to cross each other in a way that feels eerily familiar. They form shapes that look like blocks, plots, or streets, the kind of order we expect from a city grid when seen from the window of an airplane back on Earth. At first glance, it's almost impossible not to think of the remnants of a long lost settlement. The patterns are too straight, too deliberate looking, to be a random scattering of natural features, at least to the human eye. This is the quiet trick that Elysium Planitia plays. It offers a scene where the boundary between the natural and the artificial blurs just enough to ignite the imagination. Scientists who study Mars, however, offer a grounded explanation. They point to a process known as tectonic fracturing, when stress builds up in a planet's crust, causing it to crack. On Earth, similar fractures can be seen in certain volcanic plains, where cooling lava contracts and splits along fault lines. Over time, erosion can sharpen those cracks into the deep, clean lines we see from orbit. If the fractures intersect at close to 90 degrees, the result is a grid-like pattern that looks anything but accidental. Still, even knowing this, there's something captivating about the view from orbit. The high-resolution images from NASA's Mars Reconnaissance Orbiter don't just show a few random intersecting lines. They reveal entire patches of landscape divided into almost perfect rectangles. Some of these sections seem to repeat in a way that gives the illusion of structure, like the foundations of buildings or ancient roads buried under millennia of dust. The mind, trained to find meaning in shapes, begins to spin possibilities. Could these have been the remains of an alien city, eroded until only its skeleton of streets and foundations survived? Were they perhaps ancient agricultural plots, the ghostly memory of fields carved by intelligent hands? Or are they simply the product of nature's own geometry, mimicking our designs without any intention? Theories like these thrive because the images leave so much room for interpretation. Without standing there in person, without walking among the ridges and feeling the rock, we are left with photographs that capture only a moment, a certain angle, a certain play of shadow and light. And in that space between evidence and certainty, curiosity grows. For those inclined toward more speculative thinking, Elysium Planitia is especially tantalizing because of its geological history. It is not only one of the smoothest and flattest regions on Mars, but also one of the youngest in terms of surface age. Volcanic activity here may have been relatively recent, in geological terms, perhaps within the last tens of millions of years. If life or civilizations ever arose on Mars during a warmer, wetter period, this could have been a habitable plain, stable enough for building and agriculture. Even mainstream science leaves the door slightly ajar for mystery. While most experts attribute the patterns to fracturing, some admit that they don't fully understand why certain parts of Elysium Planitia exhibit such consistent alignment. There's no direct evidence of intelligent design, no artifacts, no manufactured materials, but the patterns themselves remain striking enough to keep both geologists and armchair explorers interested. The role of satellite imagery in all this can't be overstated. Without orbiters like Mars Global Surveyor or the Mars Reconnaissance Orbiter, we would never even know these shapes existed. These spacecraft act like detectives circling the planet, photographing every angle, capturing features invisible to rovers on the ground. But their high vantage point also creates a kind of double-edged sword. From far above, the mind fills in details that may not exist up close. A few shadows can become a wall, a curve of rock can turn into a corner, and the human desire for stories transforms a random pattern into the ruins of a vanished city. In this way, the rectangular ruins of Elysium Planitia are as much a reflection of our own imaginations as they are of Mars itself. They are a perfect example of how a lifeless plane can still feel alive with possibility, how the act of looking from afar can transform simple geology into a puzzle that refuses to leave our thoughts. And as the orbiters pass overhead, scanning other parts of the Martian surface, they will find more patterns even stranger, shapes even harder to explain, including spirals that twist across the land in ways no ordinary erosion should create. From the silent heights of a Martian orbiter, the red planet's surface can seem like a vast, endless wilderness of dust, rock, and scars left by ancient impacts. But then, in certain places, the landscape appears to twist into patterns so deliberate that they stop scientists in their tracks. Perfect spirals, not the kind broken or warped by erosion, but ridges that curve around themselves in precise repeating arcs, stand out against the otherwise chaotic terrain. They are large enough to be seen clearly from space, yet their symmetry feels almost intimate, as though each was drawn carefully by hand. The first time these spiral mounds were noticed in high-resolution images, many scientists assumed they were looking at a trick of the light, shadows pooling in circular depressions perhaps, or sand dunes arranged in some unusual wind pattern. But repeated imaging showed the same formations, their graceful coils unchanged by the passage of Martian seasons. The spirals weren't just shapes in the sand, they were built into the land itself. On Earth, nature can sometimes create spirals through volcanic activity. When thick lava cools and contracts in certain conditions, it can twist as it flows, leaving behind patterns in the rock. Glacial processes can also form spiraling moraines when ice moves in complex, swirling paths. But the spirals on Mars do not fit neatly into either category. Some are located in regions with no known volcanic history, and others appear in areas far removed from any signs of ancient glaciers. Their ridges are sharp, their edges clean, a sign they may not be as ancient as the planet's oldest features, yet old enough to have resisted the harsh Martian winds for thousands, maybe millions of years. For some researchers, the mystery deepens because spirals have a certain universality in the natural world. They appear in seashells, hurricanes, galaxies, and even the pattern of seeds in a sunflower. In biology, the spiral often represents efficiency, the best way to pack or grow in limited space. On a planetary surface, spirals can sometimes emerge when fluids or gases flow under the influence of rotation or changing pressure. Could the Martian spirals be the fossilized remains of some ancient process involving water, ice, or even microbial mats that once grew in circular colonies? Such ideas may sound speculative, but the thought of a biological origin is enough to keep imaginations alive. Spirals are not random, they carry a sense of intention, whether born from physics or life. This is why they spark theories of design. Humans instinctively associate them with meaning, from the carved spiral stones of ancient Celtic sites to the engineered spiral ramps of modern architecture. The shape feels purposeful, almost artistic. This same instinct fuels the more fringe interpretations. To those outside mainstream science, the spiral mounds of Mars could be the remains of some alien construction, massive symbolic shapes left behind, either to be seen from above or to serve a function long forgotten. The precision of their curves is often cited as too perfect for mere chance, especially when several appear clustered in the same area. Some point out that from orbit, the spirals resemble crop circles, only on a scale and permanence that far exceeds anything on Earth. Still, planetary scientists are careful not to leap toward extraordinary explanations without extraordinary evidence. They examine the surrounding terrain for clues, patterns in the soil, fractures in the bedrock, traces of sediment that might reveal how these spirals came to be. Some suspect that a combination of wind erosion and ancient geological layering could naturally create such shapes over immense periods of time. Others believe the spirals might be remnants of massive ice formations, their patterns preserved after the ice itself vanished. Yet even the most grounded explanations do not rob these formations of their strangeness. The fact that we can look down at an alien world and see such familiar geometry is in itself remarkable. It reminds us that order is not always the work of intelligence. Sometimes it emerges from the blind forces of nature, sculpting beauty from chaos. And it is exactly this kind of beauty, lying just beyond our reach, that makes Mars feel both familiar and unknowable. The orbiters continue to map these spirals in greater detail, tracing each curve, measuring each ridge, but no camera, no matter how sharp, can yet tell us the full story. For that, we would need to stand on the surface itself, walk the coils, touch the rock, and see the landscape from the ground. Until then, the spiral mounds remain one of those Martian puzzles that live halfway between science and wonder, much like another feature not too far away, a strange patch of the surface that gleams with an unexpected shade of blue, almost like a hidden oasis in the desert. From high above Mars, most of its surface is a study in shades of red, a world painted in rusty dust, ochre cliffs, and muted gold plains. The planet's nickname, the Red Planet, fits perfectly. But then came the images that made people stop mid sentence and look twice. In a handful of photographs, there it was, a splash of intense, almost electric blue against the endless rust. It didn't seem possible. The images weren't the blurry kind that could be waved away as a trick of the light. They were crisp, high-resolution captures from orbit, showing patches of land that shimmered in icy deep blues and bright turquoise streaks. The contrast was so sharp, it almost felt like a bruise on the planet's surface, something raw and out of place. Scientists explained quickly that the colors were partly the result of processing, the use of color enhancement to make certain features stand out. But even knowing that, the blue remained shocking. It wasn't supposed to be there, not in such vivid form. On a purely scientific level, the patches made sense. Mars Reconnaissance Orbiter and other spacecraft often use color filters and false color imaging to highlight differences in minerals, ice content, and soil composition. What our eyes see as blue in these images may, in reality, be basalt rich rock or frost covered ground, reflecting light differently than the surrounding dust. In some cases, it's the signature of certain minerals that scatters sunlight in a way that shows up as blue to the orbiter's instruments. One leading explanation is that these regions could be coated in fine grained material that has been polished smooth by wind, changing the way light bounces off the surface. Others suggest that it may be ice, thin layers of frost or frozen carbon dioxide clinging to slopes and crater edges. When hit by sunlight, these frosty patches can reflect light in ways that make them appear almost neon when the images are enhanced for scientific study. But the scientific explanation didn't stop the wave of public fascination. People aren't wired to think in terms of mineral reflectance and light wavelengths. They see a vibrant blue spot on a red planet and immediately imagine water, real, liquid, shimmering water, a hidden lake, an oasis. Even though the science says that's unlikely in the open air of modern Mars, the mind can't help but wander toward that vision. After all, on Earth, blue almost always means water, a deep ocean, a mountain lake, a clear glacier. The term blue oasis caught on quickly, spreading through headlines, documentaries, and online forums. Artists began painting it as a place where astronauts could one day stand, looking out over icy cliffs and sapphire plains. Some conspiracy theorists even suggested it was a deliberate blur in the data, hiding something NASA didn't want the public to see, perhaps evidence of life or an artificial habitat. For planetary scientists, the fascination wasn't entirely unwelcome. These striking images drew attention to a deeper truth. Mars is far more colorful than most people realize. Its surface isn't just one shade of red, but a complex patchwork of browns, golds, tans, and grays, and yes, occasionally blues. The patches revealed in these enhanced images point to changes in surface composition, erosion patterns, and temperature variations. They are clues waiting to be pieced together about the planet's more recent history. Some regions that appear blue in these images line up with areas believed to have experienced landslides or dust avalanches, exposing fresher, less weathered material beneath the surface. This younger ground hasn't yet been darkened by the planet's constant dust storms, allowing the subtle color differences to stand out more sharply. In other cases, the blue areas appear in craters that may have once been home to ice deposits, hinting at a frozen past still preserved just below the dust. The allure of the blue oasis lies not only in its beauty, but in its suggestion of something hidden, something that doesn't fit neatly into the uniform face Mars usually shows us. The patches are rare, isolated, and fleeting, often shifting in size and brightness between observation cycles. This impermanence adds to their mystery. If the surface changes, even slightly, what else might be shifting on this supposedly quiet planet? Looking at these blue splashes against the Martian red feels like catching a glimpse of the unexpected. the same feeling explorers on Earth must have had when they stumbled across an alpine lake in the middle of a desert or a glacier glowing turquoise under the sun. It challenges what we think we know about a place. And in a way, that's what keeps Mars so compelling. It's not just the ancient volcanoes or the vast canyons, it's these small, beautiful surprises that remind us the planet still has secrets. From here, the mind naturally drifts to the nearby highlands and craters, where symmetry, not color, draws the eye. Places where nature seems to have made twins, two nearly identical mountains standing side by side like silent sentinels, their shapes echoing one another across the Martian horizon. In the soft golden light of a Martian afternoon, the kind that turns the dust into a glowing haze and casts long, sharp shadows, two mountains rise side by side. They are not the tallest peaks on Mars, nor the most famous, yet they have a presence that makes them impossible to ignore. From orbit, they almost look like reflections of each other, two halves of the same thought placed carefully onto the planet's surface. Even without context, the sight stirs something instinctive in the human mind, the pull of symmetry, the quiet thrill of patterns in nature. They have been called the Twin Peaks. No elaborate names, no complex geological jargon, just a simple human description of what the eyes see. They stand close together, their slopes etched with the same kinds of gullies and ridges, their summits rising to almost identical heights. From certain angles, they even seem to lean toward each other, as if caught in some ancient silent conversation. The first time the Twin Peaks captured attention was when NASA's Mars Pathfinder mission landed in 1997. Pathfinder's small rover, Sojourner, roamed the rocks and dust of Ares Vallis, snapping pictures of the surrounding landscape. In the distance, two hazy shapes rose above the horizon. Hills, yes, but too perfectly matched to pass without comment. The images traveled quickly, and soon they were everywhere, in news reports, in school science projects, in late-night radio discussions where callers speculated about lost Martian cities and giant monuments to forgotten gods. From a scientific standpoint, symmetry in landscapes is not impossible. Mountains can form in pairs when a single uplift in the crust is split by erosion, or when two nearby volcanic cones rise from the same hotspot. Some scientists believe the Twin Peaks might be remnants of a much larger landform, worn down over millions of years until only these matching cores remained. Others suggest they could be the eroded edges of an ancient impact crater, with the peaks representing what was once part of a rim. Yet the perfect near mirroring of the two peaks is what keeps the conversation alive. In nature, symmetry often feels like intention, like someone or something shaped the land with care. Our brains are wired to notice balance and order because in our evolutionary past, spotting patterns helped us survive. A symmetrical plant might be edible, an orderly track in the sand might mean another human had been there. So when we see two mountains that could almost be copies of each other, our instincts whisper, this means something. That instinct is part of why the Twin Peaks have become a small but persistent feature in the world of ancient astronaut theories. Writers and believers in this field point to them as possible markers, like the twin pillars or gateways in mythologies across the world. On Earth, ancient cultures often built paired structures to represent balance, duality, or a symbolic entrance to something sacred. To the imaginative mind, the Twin Peaks of Mars could serve a similar purpose, a gateway to a lost valley, or markers for travelers crossing a long vanished Martian plain. These ideas find fuel in the way the peaks dominate their surroundings. The land around them is relatively flat, scattered with smaller rocks and ridges, which makes the pair stand out even more. In some enhanced images, their bases seem aligned along an invisible axis, almost as though they were positioned with precision. Of course, the rational explanation is that erosion and time simply happen to work in similar ways on two neighboring mounds. But when the shapes in front of you match so neatly, it's hard to quiet that part of the mind that loves the idea of design. Pathfinder's panoramic shots of the Twin Peaks have been studied for decades now, yet they continue to invite speculation. Even among scientists, there's an appreciation for their visual harmony. Researchers may not leap to the idea of alien architects, but they do acknowledge that such features help keep the public engaged with Mars exploration. Images like these are the ones people remember, not just because they're beautiful, but because they stir a mix of wonder and curiosity. Standing there, if you could, you might feel the scale differently than from a photograph. Each peak rises hundreds of feet into the air, casting shadows that stretch across the dusty ground. Between them lies a shallow valley littered with stones and drifts of fine red sand. The wind would whistle softly through the gap, carrying with it grains of dust that have been traveling across the planet for thousands of miles. You might look up at the peaks and feel that ancient pull again, the sense of standing before something more than just rock. The mind might wander further, wondering if early Mars, wetter, warmer, and possibly alive, once saw these peaks framed by rivers or lakes, their slopes green or dusted with snow. If anyone or anything lived here, the Twin Peaks would have been landmarks, guiding travelers across the land. Even now, for robotic rovers and orbiting satellites, they serve the same purpose, a fixed point in an ever changing sea of dust. And just beyond them, the Martian surface holds other shapes that demand attention. Not pairs this time, but strange spider like marks that seem to crawl across the ground, spreading in delicate branching patterns with the coming of spring. When the long, frigid winter on Mars finally begins to loosen its grip, the first signs of change appear not as melting rivers or blossoming plants, but as something far stranger. From orbit, vast stretches of the southern polar region seem to sprout dark, spindly patterns across their pale surface, shapes that stretch outward like the legs of enormous insects crawling through the frost. They are not alive, not in the way we understand life, yet their appearance is so organic, so alien, that the images are hard to forget once you've seen them. Scientists call them araniiforms, but to most people, they are simply known as the spiders of Mars. These strange formations were first spotted in the late 1990s when NASA's Mars Global Surveyor began sending back high resolution images of the planet's polar regions. The photos showed the smooth, icy terrain suddenly breaking into an intricate network of branching lines, radiating from central dark spots like veins or the cracks in a shattered window. From the top down, they resembled enormous spider bodies, with legs reaching out for hundreds of feet in all directions. Some appeared clustered together, forming entire colonies of these bizarre shapes. The unsettling thing about the Martian spiders is not just their appearance, but the way they seem to emerge and then vanish in a seasonal rhythm, almost as if they were breathing with the planet itself. During the long, cold winter, the south pole of Mars is blanketed by a thick layer of carbon dioxide ice, dry ice that forms a smooth, pale covering over the ground. Beneath this frozen sheet lies the dusty surface of Mars, hidden and waiting. As spring arrives and sunlight strengthens, the base of the ice begins to warm first, because sunlight can pass through the translucent dry ice and heat the ground below. The process that follows is unlike anything seen on Earth. Trapped between the ice and the soil, carbon dioxide gas begins to build up under pressure, It searches for weak points, and when it finds one, the gas bursts upward in powerful jets, carrying with it dark sand and dust from below. These eruptions stain the surface of the ice with long branching trails of material, forming the spider like patterns seen from orbit. Each leg of the spider is a path where dust was blown outward by the escaping gas. Over weeks, these marks grow more complex, with overlapping patterns weaving together into an otherworldly lacework. To the human eye, these formations feel alive, as if they're the trails of creatures tunneling just beneath the surface. Their alien quality comes from the fact that there is no direct counterpart to them on Earth. On our planet, seasonal change does not sculpt the land in such a way. We have frost, we have geysers, we have sand patterns left by wind and water, but nothing combines these forces into something so eerily organic. Even knowing the scientific explanation doesn't strip away the sense of strangeness. The fact that they are made not by creatures, but by chemistry and physics only makes them more alien. There's also the fact that the spiders are fleeting. They exist only for a season, etched temporarily into the icy landscape before disappearing again when the ice sublimates into the thin Martian air. By the time winter returns, the surface will be smoothed over once more, as if they were never there. This cycle of appearance and erasure adds to their mystery. They are seasonal ghosts, visible only to those who happen to be watching at the right time. For planetary scientists, studying the spiders of Mars is more than just satisfying curiosity. These patterns are evidence of active processes still shaping the Martian surface today. Mars may be a cold desert, but it is not frozen in time. The seasonal geysers that form the spiders hint at a planet that still changes, still breathes in its own way, even if it is inhospitable to us. Observations of these features have also provided clues about the thickness of the carbon dioxide ice, the composition of the soil beneath, and the interaction between the Martian atmosphere and its surface. Yet for the public, the spiders occupy a different space, that of visual mystery and eerie fascination. It's easy to imagine them as signs of something lurking under the ice, something hidden and active in the cold shadows. Their branching arms resemble the root systems of alien plants, the tentacles of deep sea creatures, or the movements of giant subterranean insects. When scientists first released close up images of these formations, they quickly spread online, sparking speculation ranging from the poetic to the conspiratorial. And in a way, the spiders have become a symbol of Mars's ability to surprise us. Even in places we expect to find nothing but ice and dust, the planet produces shapes and patterns that stir the imagination. They remind us that Mars is not just a static ball of rock and sand, it's a world with its own seasons, its own cycles, and its own set of rules. Rules that don't always match our earthly experience. Just beyond the sprawling spider fields, other shapes wait in the icy ground, not living, not moving, but perfectly sculpted by impact and time, forming strange rings and patterns that suggest the presence of something hidden beneath the surface. From high above Mars, the planet's surface is a patchwork of scars, ancient craters that tell the story of countless impacts over billions of years. Most are simple bowls or rugged depressions shaped by the violence of rocks from space slamming into the ground. But in certain regions, the craters take on a form that is far from ordinary. They are encircled by striking raised rings, almost like the ripples a stone makes when dropped into water, frozen in place for eternity. These are the crown craters of Mars, named for their regal circular outlines that stand apart from the battered terrain around them. At first glance, a crown crater looks like a normal impact site, There's the central cavity, the place where the meteorite struck. But then around the outside, there is a perfectly sculpted ring of elevated material, sometimes several kilometers across. From orbit, they look like giant medallions pressed into the planet's skin, each with its own distinctive halo. The precision of the rings makes them feel intentional, almost designed, as though some unseen hand shaped them for a purpose. But their origin, as with so many Martian mysteries, is tied to forces both powerful and ancient. One leading theory is that these craters are telling us something crucial about what lies beneath Mars's dusty exterior. Unlike Earth, where water flows freely across much of the surface, Mars today is bone dry on the outside. But scientists believe that beneath its crust, pockets of ice may still exist, hidden relics from a time when the planet was warmer and wetter. When a meteorite crashes into a place where such ice lies buried, the sudden impact and intense heat can cause it to vaporize instantly. This rapid release of energy interacts with the surrounding soil and rock, forcing material upward and outward, creating the raised ring that gives the crown crater its distinctive shape. This process is unlike what we see in most impacts on dry, rocky surfaces. On Mars, the presence of subsurface ice changes everything. When it's struck, the expanding vapor acts like an underground explosion, shoving the ground aside and sculpting it into the circular ridge we see from space. Beauty. It's a reminder that even in a landscape that looks dead and still, there may be reservoirs of frozen water waiting quietly below, a fact that holds enormous importance for both science and the dream of human exploration. Crown craters are more than just geological curiosities. They are markers, potential signposts pointing toward Mars's hidden ice reserves. For planetary scientists, these formations are like pins on a treasure map. Each one offers clues about where water once flowed, froze, and remained locked away for millions of years. In some cases, their patterns even hint at layers of ice and sediment interacting deep beneath the surface, layering the story of the planet's changing climate into their very structure. What makes these craters even more compelling is the possibility that their existence connects directly to Mars's wetter past. Billions of years ago, rivers carved valleys, lakes pooled in basins, and a thick atmosphere kept liquid water stable on the surface. When that atmosphere thinned and the temperature dropped, much of that water either escaped into space or retreated underground as ice. The crown craters could be physical proof of this transition, frozen evidence of the moment Mars traded its blue skies for a dusty red desert. Seen in high-resolution satellite imagery, their beauty is undeniable. The outer ring often appears smoother than the rough, jagged edges of ordinary craters, as though shaped by a gentler hand. In the low sunlight of Mars's dawn or dusk, the ridges cast long shadows that stretch across the surrounding plains, highlighting their symmetry. It's in these moments, when the planet's soft light reveals their full form, that the crown craters take on an almost ceremonial appearance, vast stone diadems resting on the forehead of Mars. Yet, for all their elegance, there is an unsettling quality to them as well. They stand as permanent reminders of violent collisions, frozen at the instant of creation. The meteorites that made them would have been traveling at tremendous speeds, hitting with enough force to release energy far greater than the most powerful nuclear bombs on Earth. The fact that such violence could also expose something as delicate and life-giving as water ice feels like one of the planet's strange contradictions, destruction revealing the possibility of survival. Studying these features isn't just about learning Mars's history, it's also about understanding its present. If underground ice is indeed widespread, it could be a vital resource for future astronauts. It could be melted for drinking water, split into oxygen for breathing, and even used as rocket fuel for journeys back home or deeper into space. Every crown crater could therefore be more than a landmark. It could be a lifeline. The raised rings also serve another purpose. They tell scientists where to focus their search for signs of ancient habitability. If liquid water once existed near these sites, even briefly, then they might have been environments where microbial life could have taken hold. Though no such life has yet been found, the search continues, and the crown craters stand quietly as part of that ongoing investigation. Not far from some of these regal formations, other shapes dot the Martian surface, vast waves of sand that seem frozen mid motion, their symmetry so perfect it looks as though an unseen tide has passed across the planet's skin. From above, they look like the surface of a vast ocean frozen in place, rolling crests and sweeping troughs, stretching for kilometers across the Martian landscape. These are the giant ripple dunes of Mars, immense wind sculpted formations that appear almost too perfect to be natural. Their lines are crisp, their spacing precise, and from a distance they seem to hum with a kind of eerie order, as if Mars itself had been combed by an unseen hand. The first time high resolution orbital images captured these dunes in detail, they sparked a strange kind of awe. Sand dunes exist on Earth, of course, in deserts, along beaches, and across dry lake beds. But on Mars, these ripples are often on a scale that defies direct comparison. Some stretch taller than a multi story building, and their wave like patterns extend so far into the distance that they seem to vanish into the horizon. There's a stillness to them that feels unnatural, as if time itself has paused mid motion, locking each curve in place. On Earth, dunes are constantly shifting, shaped and reshaped by the wind in an endless, restless dance. Mars, however, plays by a different set of rules. Its atmosphere is a thin veil, less than 1% the density of Earth's, which means winds must be far stronger to move sand and dust. Yet when those winds do rise, they have an uncanny power to shape the landscape with surgical precision. The giant ripple dunes are thought to form from grains of sand interacting with these intense, rare gusts. The low gravity of Mars also plays a role, allowing particles to travel farther before settling, creating longer, more even ridges. What fuels the fascination, though, isn't just the scale of these formations, it's their symmetry. Seen from orbit, the dunes line up in parallel rows with a spacing so regular it looks deliberate. They could be mistaken for some kind of abandoned megastructure or the remnants of ancient engineering. The mind, always hungry for patterns, can't help but imagine blueprints and intentions behind those lines. This is where speculation takes root. Could such order truly be the result of random natural forces? Scientists have worked to understand the mechanics behind these formations, studying the grain sizes, slopes, and wind patterns in regions where the dunes appear. Some are made of basaltic sand, dark and volcanic in origin, which absorbs heat during the day and releases it at night, subtly affecting the microclimate around them. Others are lighter in color, composed of minerals weathered from Mars's rocky crust. The differences in composition can influence how easily the sand moves and how sharply the crests form. What's particularly strange is that some of these ripples seem far too large to have formed under Mars's current climate. Today's winds, while capable of lifting dust into massive planet-wide storms, aren't frequent or sustained enough to easily create dunes on such a grand scale. This has led to the idea that some of these features might be relics from a different time, perhaps when Mars's atmosphere was thicker and its weather more dynamic. If true, then the dunes are not just beautiful patterns, but fossils of ancient winds, preserved for millions of years. The Martian wind itself has a character unlike Earth's. On our planet, winds are shaped by oceans, forests, and mountains, their paths constantly deflected and diffused. Mars has no oceans, few significant obstructions, and a thin, dry atmosphere that lets air currents sweep unbroken across vast plains. When these winds hit the right conditions, open terrain, loose sand, and just the right level of turbulence, they can sculpt features that seem almost mathematical in their precision. There's also the question of why these dunes stay so crisp. On Earth, rain, vegetation, and human activity quickly soften or erase dune lines. Mars, lacking all three, preserves them in a near perfect state. Even when the wind shifts, it often builds upon the same ridges instead of erasing them, reinforcing their symmetry rather than disrupting it. From a geological perspective, they are masterpieces of persistence, patterns held steady, not for years or centuries, but possibly for entire epochs. For those looking at them through the lens of curiosity rather than science, the ripple dunes invite other possibilities. Their regimented lines have been likened to landing strips, defensive earthworks, or even agricultural plots, the kind of features one might expect to see from the air above an inhabited world. Though there is no evidence to suggest they are anything but natural, the human urge to imagine stories behind the shapes we see is hard to resist. Mars seems to encourage this, offering just enough mystery in its landscapes to keep our minds reaching for hidden meanings. In the early morning light of Mars, when the sun casts long shadows across their ridges, the dunes look like dark brushstrokes painted onto the planet's red canvas. In the afternoon, as the light shifts, their contours soften, revealing subtle color variations between the crests and troughs, hints of mineral diversity and the slow work of erosion. At sunset, their edges glow, each curve catching the last warmth of the day before night sweeps over the planet and the cold seeps back in. From the ground, a rover's camera would see walls of sand rising like frozen waves, their crests cutting sharply against the pale sky. Standing among them, if one could, might feel disorienting, like being adrift in a silent ocean, with no water, no sound, just the whisper of dust sliding over dust. And beyond those silent swells, more patterns emerge across Mars's surface, shapes that defy randomness and draw our eyes toward perfection, so precise it almost seems unnatural. From high above, Mars's surface looks like a painter's canvas dotted with circles so flawless they could have been drawn with a compass. These are the perfectly round craters, impact scars so symmetrical that at first glance they hardly seem the work of chaotic cosmic collisions. They stand out even among the countless craters that cover Mars, their edges sharp and even, their proportions so precise that they look less like wounds and more like deliberate marks etched into the planet. Most impact craters on any world are round, but they're rarely this round. On Earth and the Moon, erosion, uneven terrain, and oblique impacts tend to distort the shape, leaving craters slightly stretched, irregular, or jagged. But on Mars, in certain regions, the symmetry is so exact it can feel uncanny, as though each crater is a perfect mathematical form carved into stone. From orbit, the effect is hypnotic, one after another, flawless circles arranged against the red dust, some so uniform they could be mistaken for the tops of buried silos or the bases of ancient towers. The simplest explanation, of course, lies in physics. Most meteoroids that strike Mars do so at extremely high speeds, tens of thousands of kilometers per hour, and when they hit, The force is so immense that the explosion radiates evenly in all directions, creating a circular blast pattern. If the impact happens almost perfectly vertical to the surface, the result is an even more symmetrical crater. But here's where the curiosity deepens. Vertical strikes are thought to be rare. Most objects come in at an angle, which should leave at least a subtle elongation. So, why in some places does Mars seem littered with these near perfect shapes? Part of the answer may lie in the planet's thin atmosphere. On Earth, meteoroids often break apart or slow down as they pass through the thick air, meaning they can tumble or hit at odd angles. Mars's atmosphere is so thin that incoming rocks barely notice it. They arrive still locked into their original spaceborne trajectories, and if that trajectory happens to line up with the planet's gravity just right, it produces a straight down bullseye impact. Over millions of years, enough of these chance alignments could create a landscape filled with symmetrical circles. But there's another factor: the ground itself. Mars's surface, in many places, is made up of fine dust and loose regolith lying over harder rock. When a meteorite hits such a surface, the energy disperses evenly through the soft layer before striking the bedrock beneath, helping to create a cleaner, rounder rim. It's a bit like dropping a stone into soft clay. The clay cushions the blow, but still records the outline with near perfect accuracy. From a distance, these craters can trick the mind. The precision of their curves gives them an almost architectural quality. It's easy to imagine them as the foundations of ancient structures, their upper layers buried under sand, waiting to be uncovered. This is especially true when multiple craters are spaced evenly, creating the illusion of a pattern or grid. While planetary scientists explain this as the result of statistical chance and geological coincidence, the human brain is wired to look for order, and when it sees it, it starts asking questions. Some of these craters also have unusual internal features that deepen their mystery. A few contain central mounds that are perfectly positioned in the exact middle, the result of the surface rebounding after impact. Others are remarkably shallow, their floors smooth and unbroken, as though they've been carefully leveled. In certain lighting conditions, the shadows along their rims create a sharp outline that makes them look freshly made, even if they've been sitting there for millions of years. Mars's perfectly round craters also serve as a kind of geological clock. By studying the sharpness of their edges and the amount of debris around them, scientists can estimate their age. The youngest still have crisp, steep walls and raised rims that catch the sun, while older ones have been softened by the slow creep of dust and sand, their perfect shapes gradually blurring into the surrounding terrain. Yet even the ancient ones often retain a symmetry that defies easy explanation, as if Mars's stillness, its lack of water, wind, and life, is conspiring to preserve them. There's an emotional pull to them as well. Something about the perfect circle feels intentional, as if a message has been left in plain sight, not in words, but in geometry. On a world filled with jagged cliffs, fractured plains, and chaotic boulder fields, these shapes feel controlled, orderly, even deliberate. It's the same feeling one might get stumbling across a perfect spiral seashell on a chaotic beach, or finding a smooth, round pebble among broken stones. From the ground, if one could stand there, the view inside a perfectly round crater would be striking. The walls would rise evenly in every direction, enclosing you in a bowl of rock and dust. The sky above would form a flawless circle, framing the sun as it moves across the Martian day. There would be a strange sense of symmetry, not just in the shape, but in the way sound would carry. Echoes bouncing evenly off the walls, no side louder than the other. It would feel in a way like standing in the center of a giant sundial or ancient amphitheater. And as you left that place and looked out across the landscape, you might see more circles dotting the horizon, some large enough to swallow entire cities, others small and sharp edged, like coins pressed into the soil. The perfection of their shapes would draw your eyes again and again, making you wonder if the next formation, just over the ridge, might be something more than just another crater. From orbit, some of Mars's ancient craters seem to hold a secret inside them, not emptiness, but a rise. Where you would expect a hollow basin left by a violent impact, there is instead a smooth, rounded dome swelling upward from the center, as though something beneath the surface is quietly pushing against the skin of the planet. These buried crater domes, as scientists call them, can look almost like the tops of giant bubbles frozen in mid expansion, their curved silhouettes interrupting the otherwise flat floors of the impact scars that surround them. The first time these features were spotted in high resolution images, they caught researchers off guard. Craters are supposed to be depressions, deep, shadowed, rimmed by raised edges from the impact blast. But here, in these strange cases, the center doesn't sink, it rises, and it rises in a way that is unexpectedly smooth, the slope gentle and even on all sides, like the curve of an egg hidden in the sand. The effect is subtle in smaller craters, barely noticeable until light and shadow reveal it, but in larger ones, the domes are unmistakable, standing tall enough that their edges catch sunlight differently from the surrounding floor, creating a clear division between mound and crater wall. One straightforward geological explanation is that these domes are the result of volcanic or magmatic activity. After the initial meteorite impact, molten material from deep underground could have pushed its way upward, filling the crater floor and solidifying into a dome-shaped hill. Over millions of years, wind-blown dust and sand may have softened its outline, burying part of it and leaving only the gentle curve we see today. On Earth, similar structures can be found where lava once pooled inside depressions, cooling into rounded forms that have since been covered by sediments. Another possibility is that the domes are created by the slow, almost imperceptible movement of subsurface ice. Mars has large deposits of frozen water beneath its surface in certain regions, and if a crater forms over such an icy layer, the ice could gradually push upward as it deforms or expands, lifting the soil above it into a rounded mound. The process would be glacially slow, taking thousands or even millions of years, but the planet's stillness and lack of erosion could preserve the shape far longer than on Earth. But as with many of Mars's mysteries, the story doesn't stop at geology. From the moment images of these domes became public, speculation flourished. Their symmetry, their positioning at the heart of craters, and the way they sometimes appear to form perfect circles themselves have led some to wonder if they might be something more, the remains of ancient structures now buried under layers of dust. To the imaginative eye, they could be collapsed roofs of vast underground chambers, sealed and smoothed over by time. They could be the tops of artificial installations, forgotten outposts from a lost Martian era, still hidden beneath the surface. It's an idea that gains emotional traction because of how deliberate these domes appear. Nature is chaotic, messy, but a dome, whether in architecture or in geology, speaks of containment, of something enclosed and protected. On Earth, humans build domes to shelter what's important: temples, observatories, grand halls. So when we see that same shape on another world, especially rising from the dead center of an impact crater, like the crown of a monument, our minds leap to the possibility that it might be intentional. For planetary scientists, the intrigue goes beyond speculation about civilizations. Domes are fascinating because they can act like windows into the deep past. By studying their composition, scientists can learn about the processes that took place after the crater formed, whether heat from the impact triggered volcanic activity, whether groundwater or ice reshaped the floor, or whether other geological forces were at play. The presence of a dome can indicate that the crater's history didn't end with the impact. Rather, it continued to evolve long afterward, recording changes in Mars's climate and interior. In some cases, instruments have detected differences in material between the dome and the crater floor, suggesting that whatever lies beneath pushed up distinct layers from deeper underground. In others, radar imaging hints at hollow spaces beneath the dome's surface, though the resolution isn't high enough to confirm their size or shape. Each discovery adds to the sense that these formations are more than simple mounds. They are the visible signs of hidden stories still locked beneath Mars's dust. From a visual perspective, they are quietly beautiful. The crater rim forms a sharp outer boundary, and within it, the dome rises like a second horizon. If you stood inside such a crater, the dome would dominate the landscape, its slopes broad and even, inviting the urge to climb to the top just to see the view from above. And from that peak, the world outside the crater's rim would vanish from sight, leaving only the bowl around you and the sky overhead, an enclosed otherworldly space where you might feel as if you were standing in the center of an arena built by something ancient. As more of these domes are cataloged, patterns begin to emerge. They're not scattered randomly across Mars, but seem more common in certain regions, especially where volcanic activity once reshaped the landscape. This clustering could support the geological theories, but it also adds to the sense that there may be a shared origin, a process or event that repeatedly produced this same distinctive shape. And until the day a rover or lander can investigate one up close, the mystery will remain, caught between the realms of science and imagination. From high above the Martian surface, certain dark patches of terrain reveal a strange orderliness that feels almost out of place on a planet shaped by chaos. Stretching across the ground are countless interlocking shapes, mostly hexagons, some pentagons, all fitting together as neatly as the stones in an ancient courtyard. They are not the work of any known civilization, at least not as far as science can prove, but rather what planetary geologists call polygonal lava fields. Seen through the unblinking eye of an orbiter's camera, they look almost man made. Each polygon is outlined by narrow cracks or ridges, the lines running in a way that seems too deliberate to be random. The pattern continues for hundreds of meters, a network of repeating shapes spreading like an immense tiled floor left behind by some vanished architect. In certain light, the edges cast fine shadows, making the polygons stand out even more, as if someone had traced them carefully with dark ink. On Earth, similar formations appear in volcanic landscapes, often where lava once cooled slowly and evenly over a wide, flat expanse. When molten rock solidifies, it contracts. If the cooling is uniform and gradual, the stress spreads evenly, breaking the surface into roughly equal shapes, most often hexagons. This process is the same one that creates the famous basalt columns of places like Giant's Causeway in Northern Ireland or Devil's Postpile in California. But while those columns rise vertically like organ pipes, the Martian polygons are seen from above, their outlines etched into a flat crust. In some cases, they may also form through repeated cycles of heating and cooling, or through the expansion and contraction of frozen ground beneath the surface. That's part of what makes them so fascinating. On Mars, both volcanic activity and permafrost have played huge roles in shaping the landscape. The polygons might mark the places where those forces met, where lava spread over icy ground, or where buried ice caused the crust to crack in a distinctive pattern. To the human eye, though, the geological explanation is only part of the picture. The shapes are so precise, so consistent, that they awaken a different kind of curiosity. The same instinct that makes us see design in a pile of stones or symmetry in a scatter of objects. The mind latches onto patterns because patterns suggest purpose. Even knowing the natural processes behind them, it's difficult to shake the impression that you're looking at something built. The Martian polygons seem especially uncanny because they resemble tiling we use in our own cities, from mosaic floors to cobblestone streets. In some images, the shapes are almost perfect, their sides equal, their corners sharp, as if they had been cut and placed with care. If you let your imagination wander, you could picture a plaza here, long abandoned, its stones now fused together by rust colored dust and time. What's striking is how these formations can survive so clearly for such a long time. Mars's thin atmosphere means there is little weather to erode them away. The wind may sweep across them endlessly, but without rain, vegetation, or heavy erosion, the polygons remain visible, preserved like a snapshot of the moment they first formed. On Earth, landscapes change quickly. On Mars, they endure. This permanence gives them an almost timeless quality, as if the planet itself has kept them as a kind of signature written in geometry. For scientists, studying these lava fields isn't just about their beauty or their eerie resemblance to human craft. They are also valuable clues about Mars's past. The size and shape of the polygons can reveal how fast the lava cooled, how thick it was, and what the conditions were like at the time of its flow. If ice was involved, the patterns might also hold information about when and where frozen water once existed near the surface, a critical piece of the puzzle in understanding Mars's climate history. In some areas, the polygons aren't entirely flat. The cracks between them have widened, and dust has settled into the gaps, creating subtle depth that adds to the illusion of paving stones laid by hand. Elsewhere, the polygons have been fractured or overlapped by later flows of lava, their lines interrupted like a mural that has been painted over in places. These overlapping layers tell stories of repeated eruptions, shifting ground, and the slow sculpting of the planet's skin. The resemblance to man made tiling isn't just a superficial quirk, it's a reflection of the fact that both nature and human builders work under the same physical rules. Lava cooling on Mars and a mason laying stones on Earth both respond to the same mathematical truths. Hexagons are efficient, stable, and packed together without gaps. The difference is that one is the result of conscious intention, the other the silent work of physics. Yet from a distance, the two can look almost indistinguishable. And so, when images of these polygonal lava fields reach the public, the reactions are often divided between those who marvel at geology's artistry and those who wonder whether there might be more to the story. Could these shapes be the foundations of something older than any human structure, a natural pattern that ancient eyes, if they ever walked here, might have claimed and built upon? Or are they simply one of Mars's many ways of reminding us that order does not always require a designer? As the orbiters continue to map the planet in ever finer detail, more of these patterned planes come into view, scattered across the volcanic regions like the remnants of vast forgotten courtyards. Each one is a quiet testament to the planet's complex past, etched in geometry for anyone willing to look closely. And just beyond the edges of these lava fields, the Martian surface shifts again into something stranger still, pulling our gaze onward. From far above Mars, certain stretches of land appear as if someone had pressed a vast honeycomb into the planet's surface. The ridges run in clean, interlocking shapes, pentagons, hexagons, sometimes irregular polygons, forming a continuous network that seems almost too deliberate to be natural. It's a kind of geometry you would expect in the wax chambers of a beehive or the carefully cut stones of an ancient wall, not in the open, windswept plains of a distant world. Yet here they are, etched into Mars's skin, enduring through centuries without crumbling. The patterns are especially striking because they are not shallow marks or discolorations. They rise from the ground as low ridges, some only a few feet high, others more pronounced, with dusty troughs between them. From the perspective of a rover's camera, they look like a labyrinth without walls, lines stretching away into the distance, each intersection forming a point in an unbroken puzzle. From orbit, they are even more mesmerizing, filling the frame with repetition, so perfect it feels almost hypnotic. Geologists think these honeycomb terrains may be tied to the presence of subsurface ice. On Earth, in the coldest regions like the Arctic tundra or Antarctica's dry valleys, similar polygons appear naturally. There, they are caused by a process called thermal contraction cracking. In winter, the frozen ground contracts and splits, forming long cracks. When summer comes, meltwater fills the cracks and refreezes, expanding them further and pushing up the edges to form low ridges. Over decades or centuries, this cycle repeats until the landscape is neatly divided into geometric plots. On Mars, the same principle could be at work, except on a grander and older scale. If ice lies buried just beneath the dusty crust, seasonal temperature swings might cause it to expand and contract, shaping the soil above it into these interlocking forms. The absence of rain and vegetation means the patterns would remain intact for far longer than they could on Earth, with only wind slowly softening their edges. That would explain why some Martian honeycomb terrains look so fresh, as if they were carved only a few years ago, even though they might be ancient. But the mystery deepens when you consider how widespread these formations are. They aren't confined to the coldest latitudes, where ice is expected. Some appear in mid-latitude regions where surface ice should be unstable, suggesting that either the ice is hidden deeper underground or something else entirely is responsible. Could the ridges have formed in a different era, when Mars's climate was colder and wetter? Or could they be the result of a completely different mechanism, one unique to the Martian environment? On Earth, honeycomb-like terrains can also form in volcanic areas, where cooling lava contracts in a way similar to frozen ground. But Martian examples often occur far from any obvious volcanic features. That's why scientists turn again to the idea of ice, and why each discovery of honeycomb terrain carries implications for the planet's past habitability. If these polygons do mark the presence of buried ice, they could point to locations where water has persisted for thousands or even millions of years, locked away in frozen reservoirs beneath the dust. The practical importance of this can't be overstated. For future missions, such ice would be an invaluable resource, both for drinking water and for making rocket fuel. For researchers, it's even more tantalizing because long-lasting ice can preserve chemical traces or even microscopic life, if any ever existed. In the deep cold, organic material could survive for eons, shielded from the harsh radiation that bathes the Martian surface. A honeycomb field might be more than just a beautiful geometric oddity. It could be a gateway to the most profound discoveries about Mars's history. It's not just the potential science that makes these terrains so compelling, it's also the way they tap into something deeply human. We are wired to recognize order in the world, to see repeating shapes and assign them meaning. The neatness of the honeycomb ridges draws the eye and refuses to let go. You can imagine early astronomers looking at such patterns through a telescope, wondering if they were the foundations of alien cities. Even now, with our better understanding of geology, the first glimpse of a Martian honeycomb can stir a flicker of that same thought. From a storytelling perspective, the connection to Earth is part of what makes them so relatable. If you've walked across frozen ground in the high Arctic and seen the cracked patterns stretching into the horizon, you've essentially walked across Mars in miniature. The shapes, the ridges, the slow cycles that create them, all of it has an echo on our own planet. That's why scientists study terrestrial permafrost sites so closely, flying drones over the tundra or mapping Antarctic polygons in detail. By understanding how ice and soil interact here, they can read the same stories in Mars's frozen deserts. In some cases, those comparisons lead to startling insights. For instance, the sharpness of the ridges on Mars can be compared to the blunted ones on Earth to estimate their age. Fresher ridges might mean recent activity, perhaps even seasonal changes still shaping the surface. And if the polygons are still alive in that sense, then the buried ice beneath them may not just be ancient, it might be part of an active, ongoing process, hinting at a more dynamic Mars than we often imagine. From orbit, these honeycomb landscapes look like still images, frozen in time. But when scientists piece together the evidence, they begin to imagine them as living patterns, slowly breathing with the planet's seasons. Each crack and ridge is a line in a larger story, one that stretches from the frozen plains of Earth's poles to the red deserts of Mars, and perhaps, someday, to the footprints of the first humans who will walk among them. From high above Mars, the landscape can play tricks on the mind. You expect rivers, if they ever existed here, to be carved into the ground, their winding paths etched lower than the surrounding plains. But in certain regions, the opposite is true. The rivers are raised, standing tall like ridges, as if the water once flowed along the spine of a hill rather than in a valley. These strange features are called inverted channels, and they're among the most haunting reminders that Mars was once shaped by water. At first glance, they don't look like rivers at all. They appear as long, narrow ridges winding across the surface like petrified snakes. Their edges are sharp, their courses meandering, and yet they rise above the land that surrounds them, an impossible arrangement if you think only in terms of how water behaves on Earth today. But their story is one of slow reversal, told not in hours or years, but in the patient language of erosion and time. Billions of years ago, when Mars was warmer and wetter, these channels were low places, true riverbeds where water flowed and sediment settled. Over time, as the rivers carried silt, sand, and gravel, they left behind deposits that were sometimes harder than the material around them. Perhaps the river picked up minerals that cemented these sediments together, creating a more durable layer along the channel floor. Then the climate changed. The water vanished. Wind and dust storms took over, scouring the planet's surface. The softer material surrounding the old riverbeds wore away faster than the hardened deposits inside them. Slowly, the valleys became ridges. The rivers didn't rise. The land around them sank. On Earth, inverted channels are rare but not unheard of. They can be found in the deserts of Utah or the dry river systems of Oman, where ancient waterways have been flipped in this same strange way. But on Mars, they stretch for kilometers, perfectly preserved by the thin atmosphere and the absence of heavy weather. Here, erosion is not a rapid force, it's a sculptor that works with infinite patience, shaving away grain after grain until what was once the lowest path becomes the highest. From orbit, these ridges can be traced like the veins of a leaf. Some branch in delicate forks, others run straight for long distances before curling back on themselves in great arcs. In certain places, you can see where they merge or split, hinting at the complexity of the river networks that once shaped them. For scientists, they are not just geological curiosities, they are maps to a lost Mars, outlines of a vanished hydrological system. Each inverted channel is a record of water's persistence. Its very presence means there was once enough flow to deposit materials, enough time for sediments to harden, and enough change in climate to strip away the surroundings without destroying the hardened core. And because the process that creates them requires specific conditions, both in the river's lifetime and in the long ages that follow, these features help scientists reconstruct the timeline of Mars's transformation from a blue world to a red one. The mineral content inside these channels can also hold clues to the chemistry of the water that once flowed there. Some may be rich in sulfates, suggesting evaporation in shallow streams. Others might carry clays, which on Earth often form in the presence of standing water for long periods. Such minerals are more than just fingerprints of ancient rivers. They are potential habitats, places where life, if it ever took hold on Mars, could have found shelter. Cemented sediments can trap and preserve microscopic fossils, shielding them from the harsh surface conditions that came later. Rovers that have approached these ridges up close reveal even more detail. The surfaces are often rough, with chunks of embedded gravel still visible, like a cobblestone road built by nature itself. Some ridges are only a meter high, while others tower several meters above the surrounding plains, and in some cases, they form entire networks, a raised skeleton of a river system that once threaded across the land. What makes inverted channels especially poignant is the way they invert not only the shape of the land, but the idea of what Mars is. For centuries, the planet was imagined as a static, lifeless place. Then, these ridges arrived in our images, undeniable evidence that water once carved through its surface, shaping valleys that no longer exist, leaving behind the ghostly traces of a living landscape. It's not hard to imagine what they might have looked like in their prime. Rivers glinting under a warmer sun, currents carrying sediment from distant mountains, floodplains teeming with whatever microscopic life might have existed in those times. Then, slowly, the warmth fades, the rivers dry, the wind comes, the valleys begin their slow transformation into the ridges we see now. From above, they look like scars, yes, but they are also signatures, long, unbroken lines that speak of movement, of change, of a planet that was once far more dynamic than it is today. And as the eyes of our orbiters and rovers continue to follow these winding paths, they lead us forward from one geological mystery to another, tracing the routes that water once took in a world that seems, at first glance, too dry to have ever known it. From high above Mars, there are places where the land seems to bloom outward like a frozen flower. Wide, fan shaped spreads of sediment stretch from the mouths of ancient valleys, their delicate branching patterns etched into the rust colored plains. These are the remnants of river deltas, the meeting points where flowing water once slowed, dropped its burden of silt, and built new land at the edge of a standing body of water. On Earth, such deltas cradle life, from the lush wetlands of the Nile to the tangled marshes of the Mississippi. On Mars, they stand silent, locked in place for billions of years, whispering of a time when the planet's surface was alive with rivers, lakes, and perhaps something more. The most famous of these lies in Jezero Crater, the landing site of NASA's Perseverance rover. From orbit, its outline is unmistakable, a graceful fan of branching channels spreading into the crater's interior. Each finger of sediment was once carved by water that flowed with purpose, carrying minerals, pebbles, and fine grains down from distant highlands. When the flow slowed at the crater's edge, that load settled out, layer upon layer, building the delta upward and outward. To stand there in those ancient days would have been to see a landscape in motion, channels splitting and rejoining, currents pushing sandbars this way and that, life-giving water touching everything it passed. Today, the delta is frozen in place, but it has not been erased. The thin Martian atmosphere and lack of rainfall have preserved its shape in astonishing detail. Even from space, you can trace the old channels, seeing where the water once fanned out, meandering and splitting into smaller streams, before merging again. The patterns are so familiar that our eyes immediately recognize them. They mirror the river mouths we know on Earth, a kind of geological deja vu that bridges two worlds. These formations are not rare on Mars. Other craters and basins, such as Uxwalda and Shaubatana, also hold the remains of deltas. Each one tells a similar story, water flowing steadily over long periods, not as a sudden flood, but as a persistent climate-shaping force. For scientists, this is a crucial detail. It means that early Mars was not only wet in short bursts from melting ice or violent impacts, but may have supported long-standing lakes or even seas. For deltas to form, water must be stable enough to deposit sediment gradually over decades or centuries, a sign of a more forgiving climate than the one we see today. The layers within these deltas are like pages in a book. Each band of sediment was laid down in its own time, carrying its own mixture of minerals and grains. Some layers might be rich in clays, formed in calm, still waters. Others might hold coarser sand or gravel, the signature of faster, more turbulent flows. On Earth, such layers can preserve microfossils, tiny, resilient traces of life, for billions of years. On Mars, if life ever arose, these delta layers would be among the best places to find its remains, protected beneath the weight of sediment from the radiation and cold that later took over the planet. Perseverance has already begun drilling and collecting samples from Jezero's delta, carefully storing them for a future mission to bring back to Earth. In the fine details of these samples, the shapes of grains, the chemical fingerprints of minerals, scientists hope to find not just proof of water, but clues about its chemistry, its temperature, and whether it carried the ingredients for life. Standing at the base of one of these deltas today, you'd see a slope of hardened rock, its layers exposed like the cross-section of a cake. Each layer is a memory, recording the slow rhythm of deposition, the shifting currents, the changing seasons of a Mars long gone. You could trace the arc of an ancient channel above your head, now an empty groove, and imagine the sound of water running there, spilling into a lake that shimmered in the pale sunlight. The climate story these deltas tell is one of transformation. In their prime, they marked the boundaries between river and lake, between movement and stillness. They existed in a world with thicker air, warmer temperatures, and a hydrological cycle that may have included rainfall and clouds drifting over a blue horizon. Then something changed. The atmosphere thinned, the temperatures dropped, the lakes froze or evaporated. The rivers ceased their work, leaving behind only the skeletons of their former paths. And yet the deltas endure. They are among the most compelling pieces of evidence that Mars was once capable of sustaining not just water, but the stability that life needs to take root. To explore them is to walk the edges of an ancient shoreline, one that has not shifted in billions of years. The wind still passes over them, reshaping grains of dust on their surface, but the bones of these river mouths remain as they were quiet, stubborn monuments to a time when the red planet was a world of flowing water and unbroken possibility. From here, the eye can follow the line of an old river channel back toward its source, winding across the Martian plains, an unbroken thread that hints at still more mysteries waiting upstream. From orbit, Olympus Mons dominates the Martian horizon like nothing else in the solar system. It is so vast that if you stood on its slopes, the curve of the volcano would be so gentle you might not even realize you were climbing a mountain at all. Its base stretches for nearly 370 miles, wider than the entire state of Arizona, and its peak rises over 13 miles above the surrounding plains, 3 times the height of Mount Everest. This is not just the tallest volcano in the solar system. It is a mountain on a scale so immense that human comparisons barely do it justice. And yet, at the very top of this ancient giant lies something unexpected, something that whispers of a Mars that might not be as geologically dead as we once believed. From a distance, Olympus Mons looks smooth and domed, but when spacecraft began sending back high-resolution images, scientists noticed the summit was far from featureless. Instead, it's crowned by a strange, sprawling depression. Not a single crater, but a collection of overlapping calderas, each one flat-floored and ringed with steep walls. These aren't the chaotic scars left by random impacts. They are the signature of a volcano that has erupted again and again, its summit collapsing inward after each burst of activity, then building back up, only to collapse once more. The layering of these calderas is like a geological family tree. Each one represents a separate chapter in Olympus Mons' history, stretching back hundreds of millions of years. But the real surprise came when scientists began to estimate their ages. Some appear remarkably young, possibly less than 100 million years old. On the scale of Mars' 4.5 billion year history, that's practically yesterday. In fact, a few signs suggest that parts of Olympus Mons may have seen volcanic activity far more recently, maybe even within the last couple of million years. If that's true, then Mars is not a cold, entirely silent world. Beneath its dusty crust, there may still be heat, pockets of molten rock waiting to rise. This possibility changes everything we thought we knew about the planet's geologic history. For decades, Mars was painted as a world whose major volcanic and tectonic activity ended billions of years ago, leaving only the wind to shape its surface. But a volcano that has stirred in the geologically recent past hints at a more complex story, one in which the planet's interior still breathes. Standing at the edge of one of those summit calderas, if a human could withstand the thin air and brutal cold, would be like standing at the rim of a colossal amphitheater. The walls would rise hundreds of meters above, curved and sheer, with terraces marking past stages of collapse. The floor would be eerily flat, a frozen reminder of where lava once pooled before draining away. Beyond the rim, the Martian horizon would stretch so far that the curvature of the planet would become visible, the dusty plains fading into the thin blue haze of the upper atmosphere. The summit's layered structure also tells of immense forces at work. On Earth, volcanic calderas are often temporary scars, eventually erased by erosion, vegetation, or new eruptions. But on Mars, where the atmosphere is too thin to carry much rain, and the winds, though fierce, cannot carry the same erosive power as water, These features remain preserved for millions of years. Every ridge and fracture at the top of Olympus Mons is a frozen moment in time, captured almost as clearly as the day it formed. Some planetary geologists believe the flat layers at the summit hold another secret. In certain light, their surfaces show faint textures and cracks that could be linked to cooling lava flows or even subsurface activity that warped the surface after it solidified. If Mars's volcanoes have been active more recently than we assumed, it raises questions about what might still be happening underground. Could there still be enough geothermal heat to melt ice? Could there be hidden reservoirs of liquid water beneath the crust, warmed by the same forces that built Olympus Mons? The sheer scale of the mountain also plays a role in its preservation. Mars' weaker gravity allows volcanic structures to grow much taller without collapsing under their own weight. On Earth, a volcano as massive as Olympus Mons would never survive intact. Its slopes would slump, its base would buckle. But here, the lower gravity and lack of plate tectonics have let this giant stand unchanged for millions of years, its summit calderas etched in place like the rings of a tree. And yet, even this colossal stillness might be deceptive. A volcano capable of building something on this scale does not simply fade into inactivity without reason. If there is still heat inside Mars, Olympus Mons could, in theory, awaken again, not in a catastrophic eruption like those we imagine on Earth, but in slow, powerful outpourings of lava that reshape the landscape for miles around. The thought that we might live in a time when the tallest volcano in the solar system is merely dormant, not extinct, adds an edge of anticipation to every new image sent back from its summit. From here, our eyes are drawn down its vast slopes, tracing the ancient lava flows that once spilled outward like frozen rivers, stretching across the plains toward other mysteries that dot the Martian surface. From high above Mars, where orbiters glide silently through the thin Martian sky, certain slopes seem to come alive with the change of seasons. Against the planet's rust-red surface, narrow dark lines appear, running downhill in graceful tapering shapes. They start faint and thin, then slowly lengthen as the weeks pass, as though something is trickling down the terrain. These are the dark streaks, or, as scientists formally call them, recurring slope lineae. They don't appear everywhere. They favor steep, sunlit slopes, the warmest parts of Mars, often on the edges of craters, or the sides of ancient valleys. In satellite images taken months apart, the streaks seem to grow during the Martian summer, fade in the colder months, and then return again when the temperatures rise. It is this rhythm, this seasonal heartbeat, that first captured the attention of planetary scientists. Something was moving on Mars, right now, in our lifetime. When these streaks were first spotted in 2011 by NASA's Mars Reconnaissance Orbiter, excitement spread quickly. Their shape looked like watermarks, the kind left by damp ground slowly drying in the sun. Could this mean liquid water was flowing on Mars today? Not the frozen glaciers or ancient riverbeds we've known about for years, but present-day streams, however small, running in the open air of another planet. The idea was electrifying. Water is the foundation of life as we understand it. If these streaks were caused by flowing briny water, salt-laced enough to stay liquid in the frigid Martian climate, then the possibility of habitable environments existing on modern Mars suddenly seemed far more real. Even a thin film of salty water, trickling just beneath the surface, could provide a refuge for hardy microbes. And if life could cling to existence there, it might also survive in other cold, dry worlds beyond Earth. But science is rarely simple. Over the years, competing explanations emerged. Some researchers propose that the streaks could be caused by dry avalanches of dust and sand, set in motion when sunlight heats the surface and causes grains to slide downhill. In this view, the dark color comes not from wet soil, but from the way freshly exposed material reflects light differently. Others suggested a mix of both processes, occasional dampness, but not enough to call it flowing water in the traditional sense. The challenge is that we can't just send a rover to scoop up a sample from the streaks. Planetary protection rules designed to prevent contamination from Earth microbes strictly limit how close our spacecraft can get to areas that might harbor liquid water. Until we have technology sterilized enough to guarantee we don't accidentally seed Mars with our own microscopic hitchhikers, these sites remain tantalizingly out of reach for direct study. From orbit, however, the monitoring continues. High resolution cameras capture images of the same slopes over and over, watching the streaks grow, fade, and reappear. Each Martian year adds more data, revealing patterns, how long they last, which slopes they favor, whether they appear in the same places year after year. In some locations, the streaks behave with clockwork precision, forming at the same time each season. In others, they are erratic, as though responding to more complex and hidden conditions beneath the surface. For those who imagine Mars as a dead world, these streaks are unsettling. They suggest that Mars is still active in ways we don't fully understand. Something is stirring in the soil with the seasons, a movement, a shift, perhaps even a hidden pulse of water under the thin atmosphere. To look at these images is to feel the weight of the unknown pressing in, to wonder if somewhere in those dark, narrow traces lies the signature of alien biology. And there's another layer to the mystery: the temperatures. Some streak sites warm enough to allow briny water to exist briefly before evaporating, but others are colder, far too cold for water to flow on the surface, even with salts. If those streaks truly form without liquid, then the process creating them might be something we've never witnessed before, on Earth or anywhere else. The recurring slope line also invite comparisons to the deserts of our own planet. In the high, dry Atacama Desert in Chile, rain may not fall for decades, but in rare years when moisture appears, even as mist or a thin layer of frost, dormant microbial communities awaken, bloom briefly, and then vanish again into dormancy. Some scientists wonder if Mars might operate on a similar cycle, only far slower and harsher, with life lying in wait for centuries until just the right conditions return. Every time the orbiter passes overhead and sends back another batch of images, the questions multiply. Are we watching the dance of dust and gravity, or is this the signature of water's stubborn persistence on a hostile planet? And if it is water, does it flow freely in the open air, or is it creeping just under the surface, hidden from view? The answers remain locked within those narrow lines, teasing us with their annual reappearance. From these sunlit slopes, our gaze is drawn outward again, to the vast plains below, and the other strange patterns that shape the Martian surface, some carved by wind, some by ancient rivers, and some perhaps by processes still at work in the world today. Across certain stretches of Mars, the surface looks as though it has been carefully tiled by some long-lost civilization. From orbit, vast plains are etched with repeating geometric shapes, mostly polygons, each fitting snugly against the next, stretching across the land in a pattern so orderly that it almost seems deliberate. They are not small features either. Some polygons span dozens of meters across, the lines between them cutting sharp and clean through the Martian soil like the outlines of a blueprint. The first time these patterns appeared in satellite images, they sparked whispers of alien architecture. To the human eye, they resemble the paved courtyards or stone plazas of ancient cities with their neat divisions and crisp edges. It is an easy leap for the imagination to picture these as the foundations of colossal structures, now eroded and buried by time. The resemblance is uncanny and unsettling because our brains are tuned to recognize patterns like this as products of intelligent design. But nature has its own way of creating geometry, and Mars is a master craftsman. The key to these polygonal shapes lies in heat, cooling, and the slow, patient work of time. Billions of years ago, lava poured across these plains in great glowing rivers, perhaps from the flanks of a nearby volcano or through deep fissures in the crust. At first, the molten rock moved like a living thing, flowing and folding over itself. But when the eruption ended and the lava began to cool, it contracted, and as it contracted, it cracked. It cracked. On Earth, we see the same process in places like the Giant's Causeway in Northern Ireland, where basalt columns form perfect hexagons, as if laid down by a stonemason's hand. We see it too in volcanic fields in Iceland, Hawaii, and the deserts of the American West. The science is simple but elegant. When molten rock cools evenly, it shrinks at a steady rate, creating fractures that spread out and intersect, dividing the surface into polygons. On Mars, without the softening effects of weather and plant life, these patterns remain crisp even after millions of years, preserved like ancient etchings in stone. Still, the human mind resists accepting pure geology when the shapes feel so intentional. Even knowing the science, there's a strangeness in how uniform the polygons appear from high above. Some researchers wonder if the difference in their preservation compared to Earth's examples might hint at other processes working alongside the cooling cracks, perhaps freeze thaw cycles in ancient Martian ice, or stress from the planet's thin atmosphere and wide temperature swings. The Martian climate adds another twist to the story. Temperatures there can plummet drastically at night and soar again during the day, causing the surface to expand and contract. Over time, this repeated thermal stress might sharpen and deepen the cracks, giving the polygons their striking clarity. In some regions, dust and sand have settled into the fracture lines, darkening them and making the patterns stand out even more. From orbit, this contrast between pale rock and shadowed seams makes the landscape resemble a tiled floor or the honeycomb panels of an engineered structure. It's this interplay between natural process and architectural appearance that keeps the fascination alive. To a geologist, polygonal cracking is a story of physics and cooling rates, of crystallization and stress relief. To the casual observer, or to the mind inclined toward mystery, it is something else entirely, the ghost of a city that never was, or the fossilized remains of an alien foundation. These patterns blur the line between the randomness of nature and the order we expect from design, making them some of the most quietly provocative features on Mars. And unlike fleeting seasonal changes or delicate dust formations, these polygons are permanent, or at least as permanent as anything can be on a planet battered by meteorites and shaped by the slow erosion of time. They stand as frozen records of ancient volcanic activity, mapping out the cooling of Mars's molten skin in a language of geometry. It is a language we recognize instinctively, even though we may not fully understand its grammar. From the stillness of these lava plains, the mind can't help but wander outward to other Martian features, where the land itself seems to mimic the work of builders, places where natural forces have carved shapes that feel intentional, stirring that same mixture of wonder and doubt. The planet seems to whisper through its landscapes, asking whether we are seeing only what nature created or what it left behind. Scattered across certain plains of Mars are countless tiny spheres, each no bigger than a marble, lying on the surface as though someone had deliberately poured them from the sky. In some places, they seem to cluster together in loose patches, like spilled beads. In others, they form a quiet carpet over the reddish soil, each one catching the sunlight and casting a small shadow on the dust beneath it. Seen from the rover's cameras, these spheres feel strangely out of place, as though they don't quite belong to the rough, jagged terrain around them. When the Opportunity rover first rolled across one of these fields in 2004, its cameras sent back an image that baffled scientists and stirred the public's imagination. The spheres looked so deliberate, their shapes so consistent, their edges so smooth, that they quickly earned the nickname blueberries, not because of their color, but because they seemed as oddly scattered as fruit dropped on the ground. Their actual hue was a muted gray blue against the red Martian dust, but their mystery was anything but dull. NASA's explanation came quickly, grounded in geology rather than speculation. These were hematite concretions, small solid nodules of iron oxide that had formed inside the rock over millions of years. On Earth, similar concretions appear when water slowly filters through porous rock, depositing minerals that gradually cement together into rounded forms. Later, when the surrounding rock erodes away, the spheres are left behind, freed to roll across the surface. To planetary scientists, the Martian blueberries were exciting not because they were alien artifacts, but because their very existence hinted at water, liquid water, once moving through the rocks of ancient Mars. Yet for many outside the scientific community, the perfection of their shape was hard to reconcile with randomness. They were too round, too uniform, too numerous. People began comparing them to ball bearings, musket shot, or even seeds left behind by an alien civilization. The human brain, always searching for patterns and intent, found it difficult to accept that nature alone could produce such precision. On Mars, the formation of these spheres may have been helped along by the planet's unique environment. Without rain or rivers to wash them away, without vegetation to hide them, and with only the slow grind of wind to move them, the blueberries have remained scattered almost exactly where erosion freed them. The thin atmosphere and weak weathering mean they can lie exposed for centuries, perhaps millennia, without crumbling. Over time, more have likely been revealed as dust shifts and rocks fracture, giving the impression that they are scattered endlessly across the landscape. Their size is another part of their allure. Most of the spheres are just a few millimeters across, small enough to feel delicate, but large enough to be seen clearly in rover photographs. This middle ground makes them easy to imagine as manufactured, like the pellets of industrial processes on Earth. In truth, their uniformity comes from the same physics that shapes raindrops or bubbles in molten glass. When forces act equally in all directions, the most stable form is a sphere. On Mars, as mineral-rich water moved through rock pores, the iron oxides precipitated evenly around a central point, layer by layer, creating that perfect rounded shape. Still, for every person satisfied with the hematite concretion explanation, there are others who point to the sheer scale of the phenomenon as unusual. Why so many in one place? Why so evenly sized? Could they be remnants of a biological process now long extinct? The scientific answer leans toward the consistency of the rock and mineral content in the area, the same conditions producing the same results over vast stretches of time. But the debate between natural formation and intentional design is part of what keeps these spheres in the public imagination. Even among scientists, The blueberries raise questions beyond their shape. Their distribution tells a story about the ancient environment, perhaps one with groundwater flowing through layered sediments or volcanic ash deposits. The chemistry of hematite suggests oxidation, a clue to the presence of oxygen in the past, possibly tied to water chemistry. In this way, each tiny sphere becomes a fossilized fragment of Mars' watery history, preserved on the surface for us to find billions of years later. And yet their quiet mystery remains. When the rover's wheels crush one under its weight, revealing the same solid texture inside and out, it feels like breaking open a time capsule. They are not hollow shells, not delicate bubbles, but dense and durable, as though made to last. Whether seen as natural curiosities or as possible relics of something more, they stand out against the dust like a scattering of messages we have not yet learned to read. From these silent fields of spheres, the Martian surface continues to lead the eye toward shapes that blur the line between geology and intent patterns, forms, and structures that stir both scientific inquiry and the deep human urge to imagine stories written in stone. From the first grainy black and white photographs taken by early orbiters to the razor sharp panoramas captured by today's rovers, Mars has been slowly revealing itself, and yet somehow it remains just as mysterious as ever. We have walked its valleys in our imaginations, stood on the edge of its cliffs through the eyes of machines, and traced the faint outlines of shapes that seem to whisper stories from another time. Some of those shapes have yielded to science's patient questioning. We've learned how wind can carve temples from stone, how lava can cool into perfect hexagons, how ancient rivers once snaked across a wetter world. We've held answers in our hands, or rather, in the hands of our robotic explorers, and marveled at how the strange can be explained by the quiet, persistent work of nature. But Mars does not give away all its secrets. For every mystery solved, another seems to rise from the dust. A shadow shaped like a doorway, a spiral traced into the ground, a scattering of perfect spheres glinting under a pale sun. We can propose theories, build models, compare to Earth, and still somewhere in the mind, the question lingers, could there be something more? Part of what makes Mars so compelling is this constant tension between explanation and wonder. It is a planet caught between being familiar and utterly alien. Its mountains are taller than any on Earth, its canyons deeper than anything we've walked, yet its horizons feel strangely close, as though you could reach them with a few steady steps. Its colors, rust red, ochre, muted gold, are earth tones, but its air is thin and sharp, unbreathable. It is a place that looks like home, but could kill you in seconds. And still, we dream of going there. Perhaps because we see in Mars not only a reflection of our planet's past, but also a mirror held up to our own curiosity. The urge to know, to really know what's out there, is one of the oldest human instincts. It's the same instinct that made our ancestors look up at the stars and wonder if those points of light were fires, gods, or other worlds. The truth is, we may never find answers for every strange formation and unexplained feature. Some mysteries may remain simply because time has erased the evidence, or because the forces that shape them are beyond our experience. And maybe that's all right. Mystery has its own value. It keeps us searching, keeps us asking, keeps us pushing the boundaries of where we go and what we dare to imagine. Mars reminds us that science is not the enemy of wonder. Science does not strip a mystery of its beauty, it deepens it. Every answer about Mars's geology, atmosphere, and history leads to more questions, and those questions open doors, Not the kind we've seen in rover images, but the kind that lead into the unknown. So now, after walking together through the canyons, plains, and craters of this distant world, I want to hear from you. Which of these Martian wonders do you think hides the biggest secret? Do you believe the odd shapes and patterns we've seen are entirely the work of nature? Or do you think something or someone else may have once left a mark there? Share your thoughts, your wild ideas, and even your skeptical takes in the comments below. Your theories are part of the conversation that keeps these mysteries alive. And if you've enjoyed this journey, if you found yourself staring at the images in your mind and feeling that same tug of curiosity, then this is just the beginning. There are countless other mysteries waiting beyond the thin red sky of Mars. Strange moons, hidden oceans on icy worlds, signals from deep space, each with a story worth telling, each with questions worth asking. So make sure you subscribe, not just so you don't miss what's next, but so we can explore these frontiers together. Tap the like button if you want more people to see these wonders, and share this with someone who's ever looked up at the night sky and wondered what's out there. Because the truth is, we are still in the early pages of the story of Mars and of the cosmos itself. Every image, every discovery, every mystery is a sentence in a book we're all writing together. And the more eyes and minds we have searching, questioning, imagining, the better our chances of understanding the worlds that spin in the dark just beyond our reach. So here's to the next discovery, the next anomaly, the next moment when a new image appears on our screens and makes us stop, blink, and whisper, "What on Mars is that?"